Chapter 7 Repairs, Alterations, and Manufacturer Introduction Inspection requirements are the mainstay of the parachute rigor, but of equal importance is the repair and maintenance of the parachute and its related systems. When the parachute is new, it is expected to function as designed. As it is used in ages, however, it begins to wear and its condition changes, which over time could result in a malfunction of the system. It is the rigger's responsibility during inspections to identify any condition that might result in the parachute being considered non-airworthy and dangerous. In the course of training, the rigger candidate learns to identify those conditions that may be unsafe. The trainee also learns how to undertake the necessary repairs to return the parachute to its original, airworthy configuration. As we look at repairs, it becomes very evident that inspection is the initial part of the process of any repair. As stated in Chapter 1 of this handbook, Regulations and Human Factors, it is imperative that riggers be able to distinguish between minor and major repairs. This ensures that riggers do not exceed the limitations of their certificate or endanger the parachute user. The basic rule for repairs is to return the damaged parachute or component to its original airworthy configuration. However, in many instances, the remanufacture of the parachute may not be practical or cost-effective. In these cases, there are approved repair techniques riggers can use to return the parachute to service. These techniques form an important part of the rigger's store of knowledge. To make a decision as to the confirmation for the possible need for repairs, we must first understand the Federal Aviation Administration (FAA) requirement of inspection. Inspection Process Chapter 5 of this handbook, Inspection and Packing, addresses the purpose of the 180-day cycle as required by the FAA. This action ensures that the approved/certificated parachute assembly meets the standards and conditions for safe return to service. It also becomes the cornerstone of the maintenance and repair process. The confirmation of wear or damage is critical in the determination of actions that may be needed as set forth in Title 14 of the Code of Federal Regulations, 14 CFR, Part 43, and key in the assessment of actions and clarity of the repair that may need to be performed. As is the character of any device or object, use in physical location conditions, heat, moisture, sand, dirt, over time cause wear to an item and, on occasion, misuse or improper actions during use result in damage. Certain parts or areas of a device incur more wear or damage according to use, action of handling, and contact with other components. Knowledge of this aspect should require increased or location-specific consideration during the inspection process. This recognition possibility of high wear components or areas does not decrease or eliminate the inspection of any other part of the parachute assembly. It only identifies that the wear or damage probabilities are greater at these locations. These areas are referred to as common wear or damage patterns and apply to both round and square parachutes and parachute assemblies. These types of common wear/damage pattern applies in greater detail to the parachute that is utilized as the main parachute and deployed on each jump in sport use. The inspection of a reserve canopy after deployment should be very concise and complete. Much care should be taken for a very thorough inspection of the parachute and related components. Parachutes are manufactured in two categories: approved, certificated, and non-approved, non-certificated. All reserve emergency use parachutes are approved, certificated, and are tested to FAA-required Technical Standard Order (TSO) standards. They are used and maintained by FAA standards, inspection and repaired by FAA-certificated rigger or the manufacturer, as airframe and powerplant (A&P) mechanics are used. Non-approved or non-certificated parachutes are generally main parachutes and related components, which can be packed, used, and repaired outside of FAA maintenance and repair requirements. Rigger inspections and rigger repairs are highly recommended but not required. Inspection of an approved, certificated, parachute calls for inspection of all related components, which are listed below. Related components are parts of the parachute, deployment system, harness, and container system, and any item that has responsibility for containment, deployment, or operation of an approved, certificated, parachute and are a critical part of the assembly. They must be inspected for use the same as the reserve parachute. Deployment bag, free bag, safety stow, bridle and pilot chute, slider fabric, and grommets, rapid links, soft links, rapid link covers, soft link covers, all seams and seam fabric, suspension lines and line attachments, ripcord housing and attachments, ripcord assembly, upper and lower skins of canopy, all load and non-load bearing ribs, all cross ports. All of these areas can sustain wear or damage during normal use. The event of use at very high speeds can be contributed to the possibility of increased damage from exceeding the maximum speed allowed during deployment. During inspection of certificated/approved parachutes, it is advisable to map related damage found on a chart which is shown in Figure 7.1. This chart can be used to describe the location of needed repair to a customer, assist in quickly locating the damage, and answer questions that the manufacturer may have relating to possible repair. Figure 7.1. If a rigger were to receive a damaged sport main canopy for repair, it would be advantageous to gain as much information as possible as to the cause and situation that created the damage. Inspection of the canopy should be as follows. 1. Links, condition and confirmation of barrel condition, not cracked or stripped, soft links, installation, condition, tacked in place. Figure 7.2a and b2. Slider, check fabric for rips and burns, grommets for dents, nicks, or damage.
Figure 7.3a, b, c, and d. 3.
Grommet protectors, confirm they are installed correctly and in good condition. Figure 7.4a and b4. Lines, check for burns, continuity, trim, and wear at lower section of steering lines. Figure 7.5a and b5. Stabilizers, check attachments, signs of excessive stress, fabric damage or stress, and line attachment stitch. Figure 7.6a and b. 6. Line attachments, check for stitch, material fatigue, paying close attention for damage behind the line tab. Figure 7.7a and b7. Seam starts, look for backstitching failure or fraying. Figure 7.8.8. Seam work, check for snags, pulls, loose stitches. Figure 7.9.9. Fabric, check entire canopy for burns, snags, rips, and tears and check inside cells, cross port condition, and rib damage. Figure 7.10a and b10. Pilot chute attachment, check this area excessively, inside and out, and also port tape attached to it on rib. The damage here is not always obvious. Figure 7.11. 11. Center cell top skin, from pilot chute attachment down to tail seam, inspect skin for snags, dirt, discoloration, body oil/sweat transfer. Body contact is very high and sweat transfer and contact cause much faster deterioration of fabric. Figure 7.12. A damage chart similar to the reserve chart can be created to address main canopy inspections also. Major or minor repairs. It is an age-old question among rigging technicians, one that is yet to receive a clear, understandable answer. The distinction between a major repair and a minor repair is clouded by regulations and guidance material as created and applied to the repair of aircraft. The FAA classifies repairs into two categories, major and minor. Following is the FAA's definition of both. Major repair means a repair, 1. That, if improperly done, might appreciably affect weight, balance, structural strength, performance, power plant operation, flight characteristics, or other qualities affecting airworthiness, or 2. That is not done according to accepted practices or cannot be done by elementary operations. Minor repair means a repair other than a major repair. It is recognized and allowed by the FAA that the weight and balance and power plant reference as stated in paragraph 1 under major repair is not applied to parachute repairs, but all other standards are mandatory. So, the person performing the maintenance as applies to parachutes in the view of the FAA is the one who decides if the repair or alteration is major or minor, and that person could be a rigger, a repairman, who must be employed by a manufacturer, or a person under the direct supervision of an appropriately rated and qualified rigger, person with appropriate facilities, machines, tools, and materials. The manufacturer can determine if a repair is major or minor and delegate authority to rated riggers or lofts in the field to perform repairs to their required standards and approved data. The FAA or their representative can also determine what category the task may be. Often, these authorizations considered by manufacturers are a one-time only allowance or limited to a specific certificated or an approved TSO piece or type of equipment. Now we know who is responsible to make the determination on whether a repair or alteration is major or minor, but how will they decide? For some time, the FAA has published an advisory circular, AC 120-77, Maintenance and Alteration Data, a chart to assist the technician in determining what type of repair qualifies and in which category as it applies to aircraft repair. Shown in Figure 7.13 is an example repair decision chart that riggers can use, both senior and master, to determine the processes that need to be followed when excessive wear or damage is identified during the inspection process. It allows for consideration of repair for both TSO equipment and non-TSO. It also brings into effect the need for verification of the possibility of existing safety bulletins, S.B.'S, or airworthiness directives, ADs, that may apply to the items found to be damaged during the inspection process. Contamination conditions during the inspection process. In many cases the focus is to locate and identify material damage, tears, rips, broken stitches, pulled tread, and burns, which generally are very apparent should they exist. Damage can exist in forms that are less apparent to the material properties/assembly. Much less obvious, but just as important, is contamination. Contamination conditions can be critical to the repair process, and have a direct effect as to the decision of the repair type, major/minor status. Listed below are common types of contamination conditions, their visual verification properties, and the manufacturer recommended processes too. Repair. Identification of these conditions and rigor-applied repairs determine their effect on the airworthiness of the parachute assembly. Acid contamination. Nylon that has been contaminated by acid may have irregular shaped spots of gray or dead white color. The acid-contaminated fabric may also become powdery when scraped lightly. Parachute components suspected of acid contamination may be tested with blue litmus paper. Dampen the suspect area with distilled water. Then lay the litmus paper on the area in question. If the paper turns pink, acid is present. Be careful not to touch the litmus paper, as touching the paper can cause an erroneous response. Action. If an area tests positive for acid and the affected area is known to be localized, that area should be neutralized with a solution of distilled water and ammonia. Household ammonia works. Ammonia does not damage nylon or hardware. The damaged area should be removed, and the resulting hole should be patched. If the extent of contamination cannot be determined or if it affects large portions of the parachute should be first destroyed, then disposed of. Saltwater contamination. Crystals of dry salt and the presence of pale brown circular stains are often evidence of saltwater exposure. If the parachute is allowed to dry after saltwater immersion without being rinsed in fresh water, salt crystals form, causing damage to the fabric and suspension lines. Action. Parachutes exposed to salt water should be rinsed out several times in warm fresh water in a smooth tub. Use of a water softener is recommended. Hang assembly and drying tower in accordance with the section within this chapter titled, Drying a Parachute. The maximum complete saltwater immersion limits for the parachute are listed below. The parachute assembly should be cleaned within 8 hours of immersion. Remove from service any parachute assembly or subassembly for any of the following conditions. 1. Immersion in salt water for more than 6 hours if the parachute contains cadmium-plated parts. 2. Immersion in salt water for more than 24 hours if the parachute contains stainless steel parts, i.e., slider stops. 3. Immersion in salt water and cannot be cleaned for 36 hours. Removal of perspiration. Perspiration causes damage to the parachute much like salt water does. Small amounts are not significant and may be ignored. For larger areas heavily contaminated, clean the parachute in accordance with the removal of salt water contamination section above. Removal of fresh water. Dry parachute assembly in accordance with the section titled, Drying a Parachute. Removal of mildew. The following steps should be taken when removing mildew from the parachute. 1. Wash affected area with mild soap and water solution. 2. Rinse affected area thoroughly with fresh, clear water. 3. Hang assembly and drying tower in accordance with the section titled, Drying a Parachute. Removal of petroleum products. Hydrocarbons usually do not harm nylon. Petroleum products, such as oil or grease, have a greenish or brownish appearance. Wash the affected area by repeated applications of mild soap and water solution until the affected area is clean. Each application shall be followed by a rinse in clean fresh water. Once complete, hang assembly and drying tower in accordance with the section titled, Drying a Parachute. Removal of bloodstains. The following steps should be taken when removing bloodstains from the parachute. 1. Soak the stained area in cold water. 2. Hand wash affected area with mild soap and water solution. 3. Rinse affected area thoroughly with fresh clean water. 4. Hang assembly and drying tower in accordance with the section titled Drying a Parachute. Removal of soil. The following steps should be taken when removing soil from the parachute. 1. Hang the parachute and shake to remove most of the dirt and sand. 2. Brush lightly with a soft bristle brush. 3. If the assembly is extremely contaminated, perform the following.
A. Wash only the soiled areas in warm water with a mild soap. B. Rinse affected area thoroughly with fresh clean water.
4. Hang assembly and drying tower in accordance with the section titled, Drying a Parachute. Drying a parachute. The procedure for drying a parachute is critical. Asymmetric shrinkage may occur if the parachute is dried unevenly. Perform the following steps. 1. Remove pilot chute assembly and or drogue/slider control line. 2. Hang parachute full length or the seams may experience uneven shrinkage creating a built-in turn. 3. Hang reserve parachute assembly by all 4 connector links for the same time. Cleaning the parachute. Sometimes during the inspection process, excessive amounts of dirt or debris are found caused from misuse or poor landing. Also, there are occasions when the customer may request that the assembly be cleaned. Washing a parachute is not recommended unless deemed absolutely necessary because washing it can weaken and slash or increase the permeability of the fabric. Washing can also cause shrinkage in the nylon fabric, tapes, and the other components. Do not dry clean parachutes. Parachute components may be spot cleaned or cleaned as a unit, and care must be taken that the cleaning process does not do more damage than the original soiling. Hand washing, if absolutely necessary, the following considerations/steps should be used when hand washing the parachute. 1. A mild soap or soap solution and a water softener may be used. 2. Immerse the parachute into clean, fresh water contained in a smooth vessel, such as a bathtub. 3. Do not wring the parachute fabric. Damage to fabric permeability will result. 4. Gently move items by hand until all air pockets are removed. Agitate as little as possible or damage to fabric permeability will result. 5. Empty the vessel of dirty water and refill with fresh, warm, clear water. 6. Rinse the parachute several times in warm, fresh water until rinse water is clear. 7. Hang assembly and drying tower in accordance with the section titled, Drying a Parachute. Washing the parachute is not recommended and should be avoided if at all possible. Many times more damage can be caused to the assembly with an improper wash as opposed to the dirty condition of the equipment. Approved data. Now that we have determined through inspection and use of the chart what category of repair may be required, we must obtain the needed data. This can sometimes verify our determination as to the category of repair and inform us of processes or standards. Approved is the data issue or version of data that has been identified by the developer/supplier as being the master issue or version of the data subject. It is required on major repair. This data is a key element and offers the baseline of all standards that must be met for completion of the task of returning the equipment to the user in a safe, continued service condition. Riggers under FAA jurisdiction are responsible for ensuring that repairs are accomplished according to all applicable regulations under Title 14 CFR Part 43. Repair of damage can be classified as either major, minor, or alteration. This assessment is based on the scope and complexity of the repair, and result of the task, and the experience and capability of the operator. As we know, the responsibility for determining whether a repair is major or minor rests with the rigger. The document needed to complete an inspection and subsequent repack is the manufacturer's owner's manual. The documents that offer standards for a repair are found in 14 CFR Part 43 and are worded with direct application to aircraft. This allows for confusion of FAA position of repair as it applies to manufacturers and riggers. In the U.S., all repairmen, riggers and mechanics have authority to use acceptable repair data for minor repairs without additional FAA approval. These processes are not addressed in 14 CFR Part 43 as major, minor, or alteration, and no reference is found for use on parachutes or related components. Because of this rather gray area of current repair classifications under 14 CFR Part 43, many times approved data identifies directly the classification of the repair and sets forth all needed guidelines and requirements. The standards for approved or certificated equipment apply to the reserve parachute, harness/container, and related components, and these standards can also include any automatic activation device, AAD, that may be used in an approved system. With the installation of the AAD, it must meet all manufacturer service and use standards and FAA inspection limitations. This information can be found in the rig manufacturer's owner's manual and the AAD manufacturer's owner's manual. Acceptable data is oftentimes confused with approved data. Acceptable data has been allowed under the FAA system and generally used for minor repair. It can be applied to many minor repair practices of different types and application. It is general in its nature and not a required process for an approved repair procedure. It is used by the FAA when considering approval for alteration and usually does not fall under the standard of certificated or approved TSO and major repairs. Acceptable data is applied in a very broad manner and is not to be a replacement for use of approved data when addressing the FAA major repair process. Types of approved data. Approved data to be used for major repairs and alterations may be one or more of the following. This data can only be obtained from the manufacturer or the FAA administrator. This data applies to 1. Model, size, version 2. Manufacturer specifications, approval for repairs, requirements, 3. TSO C23B, C23C, and C23D4. ADs 5. Manufacturer's SB 6. Drawings, information, or repair standards from manufacturer's research and development, R&D engineers 7. Designated alteration data offered by the FAA 8. Manufacturer's manuals, including installation and assembly instructions. The rigger is responsible to confirm the information of model, type, serial number, and date of manufacture when requesting or attempting to obtain any of the above data. It is very important when confirming the following: appropriate to the product being repaired, directly applicable to the repair being made, and not contrary to manufacturer's data.
When contacting the manufacturer or FAA administrator with request for information as listed for possible major repairs, it is advisable to confirm the following: A. FAA certification required. B. Equipment, sewing and tools. C. Materials, quantity, quality, and mil spec. D.
Skills, prior knowledge, and experience with type of repair. E. Advisability of attempting this repair. In many situations, it is a better decision, economically and for the end repair, to return the damaged equipment to the manufacturer. This answers all questions as to the quality, manufacturer FAA repair requirements, and airworthiness of the item when returned to service, and confirms that the repair meets the continued service condition. Repair techniques. The following procedures use a format that provides the rigger with all of the necessary information to complete the repair properly. It has been used by at least one manufacturer to provide the necessary documentation to riggers in the field to perform major repairs or alterations on that manufacturer's equipment. The procedures provide the following information to the rigger. 1. Applicable products, those parts of the parachute that the procedure addresses. 2. Description, brief explanation of the repair or alteration. 3. Materials, those items needed to perform the procedure. 4. Machines, those machines required to do the procedure. In addition to the machines, there may be special attachments required to do the work properly. 5. Equipment, additional tools needed, in addition to the sewing machines. 6. Procedure, the step-by-step guide through the repair. This may include a disassembly and reassembly procedure. Disassembly may be straightforward, but the reassembly instructions may provide special tips or procedures to accomplish the task. 7. Inspection, the final inspection of the finished repair. This is a very critical part. In many cases, the rigger is doing the work alone. Within the manufacturing environment, the persons doing the work generally do not inspect their own work. This is given over to dedicated inspection personnel. For the private rigger, there may be no one around to inspect the work. In the case of simple repairs, it is easy for the rigger to inspect the finished job. For more extensive repairs, such as a harness main lift web replacement, there can be several areas that need to be addressed, such as dimensions, stitching, and hardware orientation. By having an inspection checklist, the rigger can be assured of not missing any critical area. Each of the 7 sections in this chapter has a list that describes common repair procedures today's rigger might use. While not necessarily encompassing everything, the techniques used in these repairs can be expanded upon to address almost any other scenario that might be encountered. This is acceptable data as referred to earlier in the chapter. If the rigger encounters a repair that he or she is not familiar with, then the rigger should contact the manufacturer for further direction and guidance. The rigger should also remember that each procedure is just one method of accomplishing a given repair. There might be more than one, or an individual might develop a different technique to achieve the same results. The exception to this is approved data that requires a specific procedure, rating, equipment, materials, or repair process. No matter what techniques or procedures that are followed, remember that there are 3 basic requirements to follow for any proper repair procedure. 1. Knowledge to do the job, to include the required certification and authorization. 2. Proper equipment, such as sewing machines or hand tools. 3. Availability of the proper materials. The individual may be a master rigger with a complete parachute loft at his or her disposal, but, without the materials as used in the original manufacture, the correct repair cannot be made. By following these simple guidelines, riggers are always able to determine whether or not they can do the job properly. Most of today's manufacturers provide guidance for the repair and maintenance of their products. These instructions are the official guidelines that the rigger must follow. The 4 primary areas of parachute repair and maintenance are canopy and lines, container, harness and risers, and accessory components. These areas are summarized within the 7 sections of this chapter as follows. Section 1, Canopy and Lines, Section 2, Container, Section 3, Harness and Risers, Section 4, Accessory Components, Section 5, Alterations, Section 6, Manufacturing, Section 7, Miscellaneous. Section 1, Canopy and Lines. There are 2 general categories of canopies, round and square. While there are other canopy types, their construction and repair techniques generally follow those of the round and square canopies. Figure 7.14 shows a round canopy repair table, created from current military manuals, and describes the types and limits of canopy repairs, most of which pertain to military or surplus canopies. It must be mentioned that all of the services differ in their approach to methods of repair. Those called out in this book are methods that have been proven to be practical and efficient and commonly accepted throughout the parachute industry. The techniques are similar with only minor differences in seam dimensions and tolerances. While these limits are practical from the technical point of view, the economic cost may not be in many cases. Note: Ripstop tape is listed in the table as an acceptable repair for certificated round canopies. This table comes from military manuals that have not been addressed or updated for many years but are currently still in use. Contact with current certificated parachute manufacturers has proven that none currently recognize or accept this type of repair as an approved procedure and do not recommend the use of ripstop tape on any parachute in production. It is highly advised that before effecting any type of repair with the use of ripstop tape on an approved parachute that the manufacturer be contacted for confirmation and the request of an approval document before completing this type of repair. Figure 7.15 shows a table of square canopy repairs and limitations. These are for reference only. Not all manufacturers recognize the same types of repairs. The information in this table is an accepted cross-section of allowable repairs. The rigger should consult with the manufacturers to confirm what repairs are allowed on any particular canopy. Detailed information on square canopy repairs holes or snags smaller than the size of one ripstop box, 1/8 inch, 3.2 mm, may remain unrepaired as long as no more than one hole exists within any 10 inch, 25.4 cm circle. A maximum of 3 such holes or snags per cell are allowed. Ripstop tape is not authorized for use on parachutes. If the damage is enough to warrant a repair, a sewn repair must be performed. Darning is not a means of repairing any parachute currently in production. Any hole or tear up to 10 inches, 25.4 cm, in length may be repaired by a senior rigger as long as the closest area of the completed repair is at least 1 inch from the nearest seam and at least 5 inches from the nearest tape or line attachment. These are minor repairs. Any damage or hole larger than 10 inches, 25.4 cm, may be repaired by a master rigger, in either direction or involving a seam or tape. This is a major repair. Any damage that requires a repair of an area that is larger than 50% of the total area of a cell skin, upper or lower, requires cell skin replacement, and should be returned to the manufacturer. Master riggers may perform repairs that do not involve taking apart any bar tacks on the canopy unless they have the correct bar tack machine or equivalent. Special bar tack patterns are used that are not normally found in the field. In addition, removal and replacement of these stitch patterns usually weakens the fabric to the point that it is necessary to replace or reinforce portions of the panels. This should also be considered in the repairs of load-bearing and non-load-bearing ribs, as most have these types of bar tack stitches located at the ends. Before performing a repair, contact with the canopy manufacturer is very important, as some of these repair standards and limitations may vary slightly. Materials certified canopies should only be repaired using certified materials or equivalent. All replacement materials should come from the manufacturer or meet production quality and shelf life standards. Understrength thread and fabric is frequently found in the field. The only way to be sure the material meets manufacturer standards is to obtain them directly from manufacturer or locate materials recognized by the manufacturer as acceptable for the repair needed. The following are the repairs found in Section 1, Canopy and Lines. Seam restitching, canopy ripstop tape repair, round and square canopy, basic patch, round canopy, panel replacement square canopy, partial panel replacement, square canopy, rib repair, square canopy, pilot chute attachment point repair. Round canopy, non-continuous line replacement square canopy, main line replacement, square canopy, control line replacement, square canopy, cross port repair, square canopy, trim check and retrim. Some methods are covered with older processes and procedures of repair, some include the newest methods as are used by most riggers today. All methods are acceptable to provide a safe and airworthy repair, but it should always be the focus of the rigger to understand all methods and strive to utilize the best possible technique to allow for repairs to be completed to the highest possible standards. Seam restitching, applicable products, all canopies, round and square, main and reserve, description, replacement of broken or damaged seam threads. Authorized repairman, FAA senior or master parachute rigger, materials, E-thread, color to match original, machines, 301 straight stitch, light duty 7 to 11 stitches per inch, SPI, 308 zigzag, medium duty 7 to 11 SPI, equipment, scissors, seam ripper procedure on lightweight material, The rigger should first set up the machine with similar material and thickness to set the tension of the machine before sewing the actual parachute. 1. Inspect the damaged thread or seam area. If the thread is merely broken or frayed, overstitch the seam with a minimum of 4 to 6 inches at each end. 2. If the seam is gathered or bunched up, it may be necessary to cut the thread in order to smooth out the seam and then overstitch the damaged area with a minimum of 4 to 6 inches at each end. Figure A and Figure B 3. If the restitching was done on a radial seam of a round canopy, which has a tape or suspension line within the seam, make sure you did not catch the tape or line in the stitching. 4. For zigzag stitching, such as on suspension lines, a 0.25-inch overstitch on each end is standard. Figure C inspection, check that the seam tension and stitch length match the original. Make sure to check top and bottom. Make sure that you have not captured any adjacent fabric in the seam. This is a common mistake on square canopies where you may have 3 panels joining together. On radial seams, slide the seam material up and down over the tape or line to check for free movement. Canopy Ripstop Tape Repair, applicable products, all main canopies. Reserve canopies as specified by the manufacturer. Description: using ripstop tape for temporary or minor canopy repairs, authorized repairman, FAA senior or master parachute rigger. Materials: ripstop tape, color to match fabric E-thread, optional machines, 301 straight stitch, medium duty 7/11 SPI, optional equipment scissors, shot bags, wallpaper roller, and scotch tape, optional procedure 1. Spread out the canopy on a smooth surface. 2. Smooth out the damaged area and hold in place with the shot bags. Figure A 3. Inspect the damaged area. 4. Trim any loose threads and smooth any loose fabric back into place. 5. For small holes, a single side patch will suffice. For holes up to 0.5 inch in diameter or a tier, a double-sided patch is necessary. 6. If the damage is a tier, the 2 sides must be positioned so the edges touch. Use scotch tape to temporarily hold the edges together. Figure B 7. For a hole, cut a piece of ripstop tape 2 inches square. For a double-sided patch, cut 2 pieces. Figure C. For a tier, cut the tape approximately 2 inches longer than the length of the tier and cut 2 pieces. 8. For the single side patch, round the corners with approximately a 1/8 inch radius. For the double-sided patches, place the 2 pieces face to face and round the corners of both pieces at the same time. This ensures a perfect match and alignment. Figure D. 9. For the 2 x 2 inch patch, peel back one edge of the paper backing and center the tape over the damaged area. Press the exposed adhesive side of the tape to the fabric and smoothly peel the rest of the paper from the fabric with one hand while smoothing the fabric with the other hand. Figure E10. Use the wallpaper roller to smooth out the patch and remove any air bubbles from the patch. Figure F11. For a double-side patch, turn the canopy or damaged material inside out. Align the second piece of ripstop with the edges of the first and repeat the process. Again, smooth out the tape with the roller. 12. If the patch is to be a temporary one, the repair is complete. If, however, it is to be permanent, it may be advisable to sew around the edge of the patch. In this case, use the single needle machine and sew approximately 1/8 inch in from the edge of the tape. Overstitch a minimum of 1.25 inches. Figure G. Note: ripstop tape has in the past been a commonly used repair material, on F111 materials, as a short-term repair. Time has shown, however, that the adhesive used can be detrimental to the strength of the fabric over the long term. Consequently, manufacturers do not recommend its use on certificated canopies. In addition, some of the modern, coated fabrics do not accept the use of the ripstop tape without additional sewing to help hold it in place. If the damage requires the use of a sewing machine to complete the repair, it is required of certified parachutes and advised on non-certificated parachutes to utilize the parachute patch method to perform the required repair. Inspection: the ripstop should be centered over the damaged area. The tape should be smooth with no air bubbles. Double-sided patches must be aligned. If sewn, tension, edge spacing, and overstitch must be correct. Round and square canopy, basic patch repair in 1986, R.D. Raganti, a production engineer working as a master parachute rigger, created a new method of parachute repair utilizing the ripstop box configuration as observed on parachute material during production. By utilizing the material map ripstop box lines, he created the process of placing repair patches and confirming material replacement during repairs to match the existing grid and establish proper placement of the repair. This process greatly improved parachute repair techniques and is recognized today by most as the industry standard. Applicable products, all canopies, round and square, main and reserve. Description: application of a basic canopy patch, authorized repairman, FAA senior or master parachute rigger, materials, E-thread, color to match, fabric, type and color to match, machines, 301 straight stitch, light duty 7 to 11 SPI, equipment, canopy or material to be repaired, marking pencil, single needle sewing machine with E-thread, ruler, hemostat, scissors, and nippers. Procedure 1. Be sure you have found all the damage. 2. Mark the boundaries of the damage. 3. Allow 2 inches for repair and fudge factor from each boundary. 4. A 6-inch patch will cover approximately 2 square inches of damage. A 7-inch square piece of fabric will be needed to make a 6-inch patch, using half-inch seam allowance. Always put the patch on the inside of the parachute. 5. Find the center of the damage on the 131 halves-inch square piece. 6. Measure half the patch size or 3 inches out to the left of the center of damage following one ripstop line in the fabric. 7. Make a center mark and a left border mark. This will look like a T laying on its side. 8. Measure half the patch size or 3 inches up the left border ripstop line from the center line and mark the top border and left border. This will look like an upside down L. Figure 7:16-9. Count down 10 ripstop boxes from the top border and make a mark. This is the start mark. 10. Count down 14 ripstop boxes from any corner of the 7-inch square piece and make a start mark. Figure 7:17-11. Place the 2 start marks on top of each other using the hemostat to hold the 4-block seam allowance in place and sink the needle. Always sew counterclockwise around patches so that the bulk of the parachute does not have to go through the bed of the machine. Figure 7:18-12. Count up 4 blocks from the bottom edge of the patch and use the hemostat to form a corner, line up the ripstop boxes, and load each piece with the same pressure. Then, sew to the corner. Figure 7:19-13. Repeat this step until the first 2 corners are sewn down. At this point, check the last corner to assure that it will fall in the top and left border marks, upside down L, were made when the measurement step was completed. Then, sew the last 2 corners down. Figure 7:20-14. While sewing, it is important to pull the fabric at the same speed the machine is going and to set the hook in the stitch loop before lifting the foot to turn a corner. Always make a 4 to 6 inch oversew. Figure 7:21. 15. If the fabric was loaded correctly, the patch will be square and will lay flat with no bubble. Figure 7:22-16. Using the scissors, cut the damage out along the ripstop line 7 boxes in from the stitching that holds the patch on. Placing your hand between the patch and parachute while trimming prevents damaging your patch with the scissors. Figure 7:23-17. Make a diagonal cut in each corner to 3 ripstop boxes from the corner. Figure 7:24-18. Place the work under the sewing machine and, using the hemostat, grab 1 ripstop box in from the cut edge. Place the parachute fabric behind the fold back of the patch, forming a French fell seam. Do this in 2 places and seat the 1 box fold back against the patch stitch row with the tip of the hemostat. Sew around the parachute patch, repeating this process on each side. Figures 7-25 and 7-26-19. Take care that each corner is fully seated and square. Figure 7:27-20. Use the side of the presser foot as a gauge for stitching. Figure 7:28. 21. Always make a 4 to 6 inch oversew or turn the next corner on a short-legged patch. Figure 7:29-22. Inspect the work thoroughly. Hold over available light source. Figure 7:30. Note, if you pull up sharply on the top thread, the bottom thread forms a loop allowing you to cut both at once and remove the bottom thread through the fabric. Figure 7:31. Note, where the damaged parachute as if it were a mitten while cutting, and you will not cut the patch that was just carefully placed. Figure 7:32. Note, always grab the work by the threads and remove directly to the rear when removing it from the machine to avoid bunching. Figure 7:33. Round canopy, panel replacement, applicable products, all round canopies, main and reserve. Description: complete replacement of a panel section of a gore of a round canopy, authorized repairman, FAA master parachute rigger, materials, E-thread, color to match, fabric, type and color to match, machines, 301 straight stitch, light duty 7 to 11 SPI, equipment, scissors, seam ripper, marking pencil, 6-inch ruler, large pin board, and straight pins. Procedure: this process of replacing the panel is in reality a panel patch and is similar to that used in making a basic canopy patch. Because of the time and difficulty involved in removing and replacing the actual panel, that technique is best left to the canopy manufacturer. This technique is the more commonly accepted practice for major panel repair. The major issue to be dealt with in this technique is that of the amount of shrinkage that occurs during the repair. The larger the area of the panel, the more shrinkage occurs. The following procedure describes a panel replacement on a block constructed, non-continuous line canopy. A bias constructed canopy is similar, but more fullness needs to be allowed for in the cutting of the panel and sewing. 1. Lay the canopy inside out on the pin board. Pin the canopy by placing tension on the seams and making sure they are straight. 2. Cut a piece of fabric larger than the damaged panel by approximately 6 inches around all sides. Make sure that the weave of the panel matches that of the canopy. For a block constructed canopy, the bolt of fabric runs parallel down the radial seams of the canopy. For a bias constructed canopy, the bolt runs parallel to the diagonal seams. 3. Trim one side of the panel to align the ripstop weave with the cross seam. 4. Fold over the edge of the panel fabric approximately 3/4 inch and pin in place, aligning the edge with the outside of the cross seam. Figure A, 5. Smooth out the panel fabric over the damaged area and align the opposite edge over the opposite cross seam. Cut the panel fabric approximately 1 inch wider than the panel. Fold the edge under and pin in place. You now have the top and bottom cross seams of the panel in place. Figure B, 6. Stitch the outside row of stitching starting and finishing approximately 1 inch short of the radial seams. 7. Take the panel fabric along the radial seam and trim approximately 3/4 inch from the outside edge of the radial seam. Fold under and pin in place. Repeat for the opposite radial seam. Figure C. 8. Overstitch the end of the cross seam that was left open a minimum of 2 inches and proceed to and down the radial seam and then overstitch the open end of the cross seam. Repeat for the opposite side. It is advisable to hold a bit of tension on the seams as you sew to minimize the shrinkage. 9. Turn the canopy right side out. Trim out the damaged panel along the seams, leaving approximately 5/8 inch. Figure D. Also trim the excess edge of the panel as needed. 10. Fold the edge of the canopy under the panel to create the seam and pin in place. 11. Sew the inside of the panel seam in place. Again, hold tension on the fabric as you sew to minimize shrinkage. 12. Remove the canopy from the machine, being careful not to pull on the threads. Trim the threads. Inspect the panel. Inspection: check the weave alignment of the fabric panel to the canopy. Check for proper thread tension all around. Seams should be straight and parallel. The resulting size of the panel should match approximately that of adjacent panels, allowing for shrinkage. Square canopy, partial panel replacement, applicable products, most main and reserve canopies. Description: replacement of a partial panels in a canopy where the extent of the damage necessitates more than a single large or multiple small patches. Authorized repairman, FAA Master Parachute Rigger. Materials: E-thread, fabric, type and color to match. Machines: 301 straight stitch, light duty 7 to 11 SPI, 308 zigzag, medium duty 7 to 11 SPI, optional 1 inch x 42 stitch bar tack, optional equipment: scissors, seam ripper, marking pencil, 36 inch ruler, pin board or large cardboard box folded flat, straight pins, Scotch tape or equivalent procedure. The method of repair presented in this section is an acceptable data method. It is advised if possible to utilize the RD Ragonti process as viewed in the basic patch repair section to allow for higher quality of repair. Note: the repair described in the following procedure is a major tear across the bottom surface of the canopy and includes damage to a non-load-bearing rib. Disassembly 1. Determine the extent of the damage. Mark out the damaged area across the panel, following the weave of the fabric. Unpick the loaded seams that hold the damaged fabric for at least 8 to 10 inches past the damage area mark. It is always easier to unpick more of the seam to allow better access to the damaged area. Restitching the seam is one of the easiest operations. Fighting the canopy is not. 2. Unpick the non-loaded seam the same distance as the loaded seams. 3. Lay the canopy on the floor, take the pin board or cardboard box and position it under the damaged area. Take the Scotch tape and tape the raw edges of the tier together to stabilize the panel. Figure A, 4. Pin the damaged panel to the pin board. Do not overstretch the fabric, but make sure to take all the slack out so the panel is square. In this instance, the canopy had spanwise reinforcing tapes, which were used to stabilize the canopy. However, one of them was damaged and requires replacement. Figure B, 5. Mark a line on the fabric at least 2 inches from the damage area on both sides of the damaged panel. Figure C, Reassembly 1. Cut a piece of fabric approximately 6 inches wider and longer than the damaged panel area. Make sure that one of the edges is straight and even with the weave of the fabric. Trim one of the adjacent sides at 90 degrees to the straight edge. 2. Mark a line parallel to the straight edge at 3/4 inch from the edge. Center the new panel on the damaged one. Fold the fabric on this line and pin in place along the damaged line. Figure D, smooth the new panel fabric over the damaged panel to the opposite side. Trim the new panel 3/4 inch longer than the damaged line. Fold the fabric at the line and pin in place. Figure E, 3. Check the tension of the two panels. They should be equal. 4. Take a straight edge and mark the location of the spanwise reinforcing tape. Figure F, 5. Sew the panel along the outer edge at 0.12 inch from the folded edge. 6. Turn the panel inside out. Trim the damaged panel at 0.62 inch from the edge of the panel edge. Figure G7. Fold the fabric under to create a French fell seam. Sew a stitch row 0.12 inch from the folded edge. 8. Sew a piece of reinforcing tape on the bottom of the replacement panel along the line for the spanwise reinforcing tape. Figure H, 9. Repair the non-load-bearing rib with a 3-sided patch. Figure I, 10. Draw a line along the edge of the partial panel on each side from the point where the old panel meets the new one. Trim the fabric along this line. Figure J. 11. Check the tension of the new partial panel piece against the edges of the other panels that formed the original seam. They should all be equal. Figure K, 12. Refold the original seam with the 3 panel edges and stitch as per the original seam. Figure L, overstitch a minimum of 2 inches on each end. 13. If a line attachment has been removed for the repair, the tab must be replaced. Make sure that the line/tab does not have a twist in it. Locate it at the correct location and reattach as per original. Inspection: check the fabric tension of the replaced panel. It should be equal to that in the remainder of the cell. Spanwise reinforcing tape should be straight and sewn. Seams should be folded correctly and thread tension even along both rows of stitching. Lines should be attached correctly and have no twists. Square canopy, rib repair, applicable products, square canopies, main and reserve. Description: rib repair on a square canopy, authorized repairmen, FAA Master Parachute Rigger mains and reserves, FAA Senior Parachute Rigger, mains. Materials: E-thread, fabric, type and color to match, reinforcing tape, type and color as per original. Machines: 301 trade titch, medium duty 7 to 11 SPI, 1 inch x 42 stitch bar tack, double needle with puller attachment, optional, and SPI to match original. Equipment: scissors, seam ripper, marking pencil, ruler, pin board, straight pins, and patching. Square procedure: repairing a rib of a square canopy is similar to doing a partial panel repair. The biggest difference comes when the rib is either 1. A loaded rib, or 1 with support tapes for the line attachment points, or 2. A crossport is damaged and needs to be repaired and recut. In this case, the crossport area needs replacement. Figure A, Disassembly 1. Determine the extent of the damaged area and unpick the top and bottom seams to access the rib. Figure B, in most cases, restitching the rib to the top and bottom panels is fairly straightforward. Because of this, opening up the seam for a good distance, 18 inches plus either side of the proposed patch, allows easier access and sewing. 2. Pin the damaged rib to the pin board to stabilize the material for marking. Mark out the damaged portion of the panel, following the weave of the fabric. Figure C, this will be the patch fold lines and the limits of the partial rib panel. Note: the tiers of the crossports have been taped together and that the crossport has been pinned down to stabilize the fabric during the marking process. 3. Using the patching square, mark a parallel line 0.75 inch inside the patch fold lines, and then another 1.62 inch inside the second line. Figure D, the inner lines are the trim lines for the rib patch. Reassembly 1. Cut a piece of fabric approximately 4 inches wider and longer than the damaged panel area. Make sure that one of the width edges is straight and even with the weave of the fabric. 2. Fold the straight edge 0.75 inch from the edge and pin in place across the damage line. Make sure the fabric is centered on the existing panel. 3. Remove the pins from the crossport area and smooth the new panel fabric over the damaged panel. 4. Fold the new fabric outwards at the patch fold mark and pin in place. Use the patching square to mark a line at 0.75 inch in from the fold line. Figure E, 5. Trim the repair panel at the inner line, fold under and pin in place. Figure F. 6. Check the tension of the two panels. They should be equal. Mark the top and bottom edges and the crossport location. Figure G and Figure H7. Remove the rib from the pin board. So the two outboard seams approximately 0.06 inch from the edge with a single needle. Figure I, 8. Trim the original damaged panel to the trim lines. Figure J, fold the fabric under to create a French fell seam. Repeat with the opposite seam. Figure K, 9. Sew the inside row to complete the seam. Figure L, 10. Cut the new crossport to match the original location and shape. Figure M, 11. Trim the top and bottom edges as marked. Figure N, 12. Pin the top seam back onto the top panel. Sew in place with either the single needle or, if available, with the double needle machine and puller. Figure O, repeat with the bottom seam. 13. Inspect finished work. Figure P, inspection, seam alignment should be straight. Check the tension of the replaced rib material. Make sure the seams are restitched correctly. Verify that the crossport is cut correctly. The line attachment tape must be replaced correctly with no twists in the suspension line. Square canopy, pilot chute attachment point repair, applicable products, square main canopies, description, repair of the main canopy pilot chute attachment point. Authorized repairman, FAA master parachute rigger, materials, E-thread, fabric, type and color to match, reinforcing tape, type and color to match, reinforcing fabric, type and color to match, machines, 301 straight stitch, medium duty 7 to 11 SPI, 308 zigzag, medium duty 7 to 11 SPI, 1 inch x 42 stitch bar tack, equipment, scissors, seam ripper, marking pencil, and 12-inch ruler procedure. This repair is quite common. If the canopy is inspected regularly, the beginnings of the damage will be noticed and a simple restitching will solve the problem. However, many times it is not, and the resultant damage is quite extensive, requiring repair of the rib, as well as the top panel. Disassembly 1. Inspect the area to determine the extent of the damage. Figure A, if the stitching that holds the attachment point to the canopy is simply coming loose, restitch as per the original. 2. If the canopy fabric is damaged, then turn the canopy inside out. The center rib should have a reinforced area that brackets the attachment point. Figure B, 3. Detach the top of the rib from the top surface of the cell where the attachment point is located. Figure C, if the rib is damaged, then a rib repair is needed. 4. Usually the top skin of the cell needs to be repaired. Again, depending on the extent of the damage, either perform a patch on the panel or a partial panel replacement. Reassembly 1. After the top skin is repaired, a new reinforcement patch needs to be installed on the center of the cell so that it is centered over the attachment point. 2. Take the pre-cut reinforcement panel and sew it in place with 2 rows of the single needle machine. The corners should be folded in at a 45-degree angle to eliminate any point loading on the corners. Figure D, 3. Reattach the rib to the top surface of the canopy as per the original configuration. 4. Install a new pilot chute attachment tape and ring at the appropriate location. Figure E. Inspection, check that rib and panel repairs have been made as needed. Verify the new top reinforcing panel is in place with 2 rows of single needle stitching. Check the new attachment tape and ring for the appropriate stitch pattern. Round canopy, non-continuous line replacement, applicable products, round canopies, main and reserve. Description, replacement of a suspension line on a round canopy with non-continuous line configuration. Authorized repairman, FAA master parachute rigger, materials, E-thread, suspension line, type and color to match, machines, 308 zigzag, medium duty 7 to 11 SPI, 1 inch x 42 stitch bar tack, optional equipment, packing table, scissors, seam ripper or scalpel, marking pencil, 6-inch ruler, 60-pound fish scale or equivalent, and finger trapping needle procedure. The most common need for this type of repair today is as a result of the suspension line of the reserve being damaged during packing or occasionally during use after landing. The newer, lightweight braided lines are very susceptible to being snagged on the hook portion of Velcro closures on the container if care is not taken by the rigger. Disassembly 1. Lay the canopy out on the packing table. Straighten the canopy ensuring the apex is straight and even tension on the lines. 2. Remove the damaged line from the canopy. Reassembly 1. Cut a new line from the same material as the original, approximately 36 inches longer than the damaged line. 2. Pre-stretch the line by applying approximately 10% of its rated strength for a minimum of 15 minutes. 3. Attach the line to the connector link in the same manner as the original. Most of the newer canopies use braided line and a finger trap attachment technique. Figure A, 4. Zigzag or bar tack the line, whichever is appropriate. 5. Run the free end of the line to the canopy. If the canopy utilizes a V-tab configuration, route the line through the V-tab. Figure B6. Pull the V-tab down until it is even with the rest of the skirt. Mark the line at the edge of the skirt and pin in place. Figure C7. Sew the line to the canopy with the zigzag machine duplicating the original manufacture. Figure D. Trim the excess line from the canopy. 8. Return the canopy to the packing table, straighten, and apply tension. Check the trim of the replaced line against the others. Inspection. Verify the line length is the same as the original with the same tension. The connector link and canopy ends must be sewn correctly. Square canopy, main line replacement, applicable products, square main canopies. Description: replacement of main suspension lines of square canopies. Authorized repairman, FAA senior or master parachute rigger. Materials: E-thread, machines, 308 zigzag, medium duty 7 to 11 SPI, 1 inch x 42 stitch bar tack, optional equipment: scissors, seam ripper or scalpel, marking pencil, 6-inch ruler, finger trapping needle, and 60-pound fish scale or equivalent procedure. Many of the modern canopies are using Spectra or other aramid fibers in place of nylon or Dacron lines. These materials are stronger, lighter, and less bulky. An example is the 825-pound Spectra line common on many main canopies. The strength is higher but the bulk is smaller than the 525-pound Dacron used in the past. Accordingly, the techniques needed to work this material are more refined and precise. Disassembly 1. Lay the canopy out on one side and straighten the lines. 2. Remove the damaged line. If the cascade is undamaged, remove the cascade line from the junction of the main line. If the cascade is damaged, remove it as well. Reassembly 1. Cut a new main line approximately 24 inches longer than the old one. 2. Finger trap a loop at the connector link end. Figure A. Make sure that the size of the loop duplicates the original or adjacent lines. If the loop is made too small, there may be difficulty in changing connector links or risers as needed. Sew the finger trap with either a zigzag or bar tack. 3. Pretension the line. With Spectra, load the line with approximately 30 pounds for 30 seconds. Place the line on the connector link. 4. Feed the running end of the line through the slider and directly to the line attachment tape on the canopy. Make sure that there are no twists to the line or it is around the other lines. Run through the attachment tape and recreate the original knot. Figure B, 5. Tension the line using adjacent lines for reference. Figure C, 6. Mark the location for the entry point for the cascade line. Figure D. 7. Cut a piece of line approximately 18 inches longer than the original cascade. 8. Finger trap the cascade into the main line and sew with either a zigzag or bar tack. Figure E9. Attach the main line to the line attachment loop as per the original knot configuration. 10. Tension the line against the adjacent lines and secure the knot. Figure F. Repeat with the cascade. 11. Finger trap the running end of the lines and sew with either a zigzag or bar tack. Figure G. Inspection. Check the length of the main line and the cascade line under tension against adjacent lines. Check stitching such as zigzag or bar tacks. Check line continuity. Square canopy, control line replacement, applicable products, square main canopies. Description: replacement of the control line assemblies on square main canopies. Authorized repairman, FAA senior or master parachute rigger. Materials: E-thread, color to match, suspension line, type and color to match. Most control line assemblies utilize 2 or more types of line, one for the upper control lines and a stronger one for the lower control lines. Machines: 308 zigzag, medium duty 7 to 11 SPI and 1 inch x 42 stitch bar tack. Optional equipment: scissors, seam ripper, marking pencil, 6-inch ruler, tape measure, and small safety pins with marker flags. Procedure: some manufacturers provide line measurements for their canopies in their owner's manuals. If so, the rigger should thoroughly measure the control line assembly and compare the measurements against those in the manual. Over time and use, the control lines have a tendency to stretch and change dimensions. At the same time, the rigger needs to compare the right and left side assemblies against each other for any differences. It is not uncommon for the left and right control lines to be different lengths, having been changed to remove a slight turn or change the opening characteristics. Figure A is a sample chart that the rigger can fill in to document the various dimensions needed to repair or replace control lines. Disassembly 1. After measuring the control lines, remove them from one side only. Leave the other side for a reference to check the new lines against both for measurements and construction. Reassembly 1. Determine how many upper control lines there are on the canopy. 4 is the most common, and this procedure uses this number for the example. With 4 upper control lines, there are really 2 continuous lines forming the assembly. Each pair of upper lines is folded in the middle to form 2 legs of the upper assembly. Each line is therefore measured at twice the A dimension plus 12 inches. If the upper control lines have different lengths, make sure to use the longest measurement to determine the cut length for A. Figure A2. Using a finger trapping needle or wire, finger trap a loop at the center of each of the lines so the result is a line with a loop at the center with 2 legs extending from it. Figure B, the eye of the loop should be no more than 0.25 inch with the finger trapped portion 1 inch long. Bar tack or zigzag the finger trap section. 3. There are 2 types of lower control line configurations, a continuous line and a non-continuous line. The continuous line is one piece with a brake loop finger trapped into it at the proper location. The non-continuous line consists of 2 pieces that form the upper-lower and lower-lower control line, as well as the brake loop. The continuous line configuration is found primarily on the older generation main canopies and on many of today's reserve canopies. The non-continuous configuration is found on most of the modern main canopies due to the ease of replacement because of wear. Continuous line method 1. Take a piece of line used for the lower control line and cut a line equal to the B dimension in figure A plus 12 inches. On this line, measure from one end 8 inches plus the C dimension from figure A and mark at that location. This will be the bottom of the brake loop. Mark the brake loop location according to figure C. 2. Take another piece of the lower brake loop line approximately 12 inches long. Finger trap the brake loop assembly according to figure D. Make sure the ends are scissor cut and tapered. Bar tack or zigzag the assembly. Figure E. 3. Measure and mark the C dimension from the bottom of the brake loop. Run the bitter end of the lower control line through the eyes of 2 of the upper control lines and finger trap the line back into itself. Figure F. Adjust the finger trap to allow for shrinkage. This completes the continuous line method of lower control line fabrication. Non-continuous line method 1. Take a piece of line used for the lower control line and cut it at the C dimension from figure A plus 12 inches. Mark at 6 inches from one end and finger trap a loop 0.5 to 1 inch long as per figure G. 2. Take a second piece of control line material and cut it to the D dimension from figure A plus 12 inches additional. Mark at 6 inches from one end. 3. Finger trap this line through the loop at the end of the upper-lower control line. Make sure there is a minimum of 4 inches finger trapped in the line and that the lower loop is tight against the upper loop. 4. Bar tack or zigzag the finger trap portions to secure them. Figure H. 5. Measure and mark the C dimension from the bottom of the brake loop. Run the bitter end of the lower control line through the eyes of 2 of the upper control lines and finger trap the line back into itself. Adjust the finger trap to allow for shrinkage. This completes the non-continuous line method of lower control line fabrication. 6. Measure the upper control lines according to dimension A plus 0.5 inch. If the upper control lines are of uneven dimensions, make sure that they are marked accordingly. 7. Lay the canopy on the floor with the trailing edge flat and straight and the line attachment tabs exposed. Lay the upper control lines so that they run to the correct attachment points and route them through the tabs. Figure I. 8. Make sure that the lines do not have a twist in them and finger trap the lines back into themselves with a minimum of a 4 inches finger trap. Leave the running ends exposed. Figure J. Do not trim the excess line. 9. Anchor the brake loop securely and apply tension through the complete control line assembly. Measure the dimension A plus B starting at the outside corner of the trailing edge. Adjust the tension of the finger trap to allow for shrinkage. Pin the finger trap section with a marker flag. Figure K. Repeat with each upper control line until complete. 10. After setting the dimension for each upper control line, bar tack or zigzag each section. Trim the excess so that the end retreats into the line. 11. Measure the dimension D on the lower control line to set the toggle location. Figure L. If the canopy is on risers, route the lower control line through the guide ring and tie the steering toggle in place. Inspection. Check finished dimensions against original dimensions according to figure A. Check that all finger trap junctions are secured with either a bar tack or zigzag. Make sure that there are no twists in the lines. Check that the steering toggles, if used, are tied on securely. Square canopy, crossport repair, applicable products, square main canopies with crossports, description, repair of damaged crossports in square main canopies, authorized repairman, FAA senior or master parachute rigger, materials, E-thread, color to match, fabric, type and color to match, machines, 301 straight stitch, medium duty 7 to 11 SPI, equipment, scissors, seam ripper or scalpel, marking pencil, 6-inch ruler, pin board, straight pins, patching triangle, and hot knife procedure. There is no limit as to how many crossports may be repaired on a main canopy. Reserve canopies are another matter. The number and authority to repair crossports on a reserve varies between manufacturers. Before attempting to repair the crossports of a reserve, first check with the manufacturer. Disassembly 1. Many times, when the crossport is damaged, there is extensive gathering and distortion of the fabric. Before progressing, smooth out the fabric to reshape the rib as close as possible to its original shape. Reassembly 1. The basic idea of the crossport repair is a 3-sided patch sewn the same as a standard French fell seam patch. The fourth side is open and recut to the shape of the crossport. Figure A, however, if the damage is extensive enough, it may be advisable to patch the complete crossport area and then recut the crossport in its original shape with a hot knife. 2. Pin the rib to the pin board. 3. Mark out the damaged area as you would a standard patch. Lay the patch material in place and pin. 4. Sew the patch in place with a seam 1/16 inch from the edge. 5. Turn the patch over, fold the seam, and sew as a standard patch. Figure B, 6. Lay the repaired rib on a suitable surface and recut the crossport shape in the exposed edge of the patch material with a hot knife. Figure C, inspection. Verify the seams of the patch are even and thread tension is correct. Hot knifed edge of the crossport must be smooth and even. Square canopy, trim check and retrim, applicable products, square main canopies. Description: retrimming the suspension lines of main canopies to return to the original trim specs, authorized repairmen, FAA senior or master parachute rigger. Materials: E-thread, machines, 308 zigzag, medium duty 7 to 11 SPI or 1 inch x 42 stitch bar tack, optional equipment, scissors, seam ripper or scalpel, marking pencil, 6-inch ruler, 25-foot tape measure, and pony clamp procedure. Checking and retrimming main canopies is a common requirement for riggers. All canopies and all kinds of suspension lines get out of trim in time with use. The rigger that knows how to quickly check the trim on a customer's canopy, and then determine how much work it takes to return it to the original configuration is performing a valuable service. In most cases, as long as the suspension lines are in good condition, retrimming a canopy adds hundreds of jumps to the life of the canopy and returns the performance to almost as good as new. The chart shown in Figure A is tailored to apply to normal ram air canopies. Certain designs, such as elliptical canopies, may have non-standard trim measurements that require more detailed measurements. The rigger should consult the manufacturer's manuals or technical data for these canopies. Disassembly 1. The first thing the rigger must do is to complete a measurement of the lines of the canopy. The chart in Figure A shows a matrix for measuring the lines of the canopy. Simply fill in the boxes for each dimension measured. 2. Start by laying the canopy on the left side, anchor the connector links, and flake it out as if for packing. Most canopy lines are measured from the inside of the connector links, which is called the 0 point. 3. Anchor the end of the tape measure even with the 0 mark at the end of the lines using the pony clamp. Figure B, 4. Start with the top outside right front corner line of the canopy. This line will be line 1A. Depending on the number of cells to the canopy, on a 7-cell canopy, the left corner line will be line 8A. On a 9-cell canopy, this line will be line 10A. Make sure that the canopy is oriented correctly so that the measurement sequence follows the boxes on the chart. 5.
Measure all the A lines first and then proceed to the B, C, and D line groups.
The lines should be measured under approximately 10 pounds of tension. As the rigger moves through the lines and changes riser groups, the end of the tape measure should be moved to the corresponding connector link and reclamped. 6. Measure the control line groups and fill in the boxes. Reassembly 1. Compare the measurements to the original line lengths as in the manual. 2. Depending on the type of canopy and type of line used, most canopies tend to have the center A lines stretched due to the load on opening. The outside lines that attach to the stabilizers and the control lines tend to shrink due to the friction generated by the slider on opening. The key concept to remember is that the length of the lines is not the critical dimension. What is most important is the trim differential, which determines the angle of attack of the canopy.
The trim differential is the difference in the line length between the A, B, C, and D lines.
The most accurate method of measuring this is to use the A lines as the base dimension and then measure AB, AC, and AD. This method takes into consideration the tolerance allowed. This dimension is what makes the canopy open and fly correctly. If the overall length of the lines is 2 to 3 inches longer or shorter, but the trim is correct, there is probably no appreciable effect on the canopy. With this in mind, it may be desirable to shortline the canopy during the trim process in order to not have to replace any main lines. 3. Because of the fact that the cascaded main lines may stretch at different rates, the adjustment to be made to the lines that have stretched, i.e., gotten longer, needs to be done at the canopy end and not at the connector link. 4. Remove the bar tacks or zigzag stitching at the canopy end of the lines. 5. Adjust the line length as needed to return to the original dimensions. Retie the knots or finger trap as necessary and re-sew as per the original. 6. For the lines that may have shrunk in length, it may be possible to gain as much as 2 to 3 inches of line adjustment by utilizing the extra line that is finger trapped into each line attachment point. Depending on the type of line used on the canopy, the amount of excess line finger trapped may vary. Dacron lines can have as little as 2 to 3 inches inserted into the finger trap and hold securely. The smaller and more slippery Spectra line is recommended to have at least 6 inches of line inserted into the finger trap. So, depending on the amount of line that is needed to be gained for the trim adjustment, the rigger may be able to adjust each end of the line to gain the necessary adjustment. 7. If this needed line can be gained, remove the bar tacks or zigzag at each end of the line and reattach after adjusting the length. Before permanently attaching, the rigger should simply tie the lines in place and check the trim. If everything is within limits, then retie or finger trap and restitch with bar tacks or zigzag as per the original. Inspection: check final trim dimensions against original, check continuity so there are no twists or cross lines, verify all junctions are either knotted or finger trapped and sewn as per the original. Section 2. Container repairs share some techniques with canopy repairs, such as single side patches. Most repairs, however, involve replacement of panels or flaps, Velcro, grommets, plastic stiffeners, worn binding tape, and broken hand tackings. Even more so than canopy repairs, the cosmetic results of the container repair are most important to the customer and, thus, the rigger. A shiny repair to the container is immediately obvious each time the user puts on the parachute. Even if it is functional, it has to look good to instill confidence in the user. The following are repairs found in Section 2: Container fabric panel repair, container grommet replacement, container Velcro replacement, container plastic stiffener replacement, main container side flap replacement, bottom of container BOC pocket replacement, 3-ring release housing replacement. Container fabric panel repair, applicable products, all types of parachute container systems. Description: application of a patch repair to container panels. Authorized repairman, FAA senior or master parachute rigger. Materials: E-thread, color to match, fabric, type and color to match, nylon tapes, assorted types and widths, such as Type 3, Type 4, or Type 12. Machines: 301 straight stitch, medium duty 7 to 11 SPI and 308 zigzag, medium duty 7 to 11 SPI. Equipment: scissors, seam ripper or scalpel, marking pencil, 6-inch ruler, hot knife, hot glue gun, butane lighter, ripstop tape, optional, and straight pins. Procedure: besides holding the canopy, the container's main function is to protect the canopy from damage. To that end, a certain amount of wear and damage is to be expected. The most common repairs involve restitching broken threads and binding tape repairs. Other damage involves tears, punctures, and fabric abrasion. The appropriate repair varies according to need. There are 5 primary repair procedures to basic panel repairs: restitching, binding tape repair, hidden patches, overlay patches, and single-side fabric patches. Disassembly 1. Remove all extraneous parts from the container, including canopies, handles, toggles, etc. 2. Inspect the damaged area to determine which repair method is appropriate. Reassembly restitching 1. Using the same type and color of thread, sew directly over the original stitching. The amount of overstitch may vary according to location. If the affected area is completely exposed and accessible, overstitch the ends of the damaged area a minimum of 1.25 inches. If this is not possible, then backstitch a minimum of 3 stitches to lock the ends. Repair complete. Binding tape repair or splice 1. Many times the binding tape is worn through due to bridle abrasion or other wear patterns. Figure A. Rather than remove the panel and rebind it, a practical and cost-effective repair is to overlay a section of new binding over the damaged area. 2. Cut a piece of binding tape a minimum of 1 inch longer than the damaged area. Scissor cut the tape and then lightly sear with the butane lighter. Figure B. If the tape is cut with a hot knife and then folded, the cut edge cracks at the hot knifed end. Searing with the lighter results in a more flexible end. Fold the tape in half lengthwise to form a crease. Take a marking pencil and mark the crease. Figure C3. Overlay the new tape over the damaged area and mark the start of where the new tape begins and covers the damaged area completely. Figure D4. Overstitch the original tape on the inside row up to the point where the new tape is to start. Leave the needle in the material. Place the folded tape over the damaged area and hold tightly in place. Make sure that the edge is pushed up against the original and the end is against the needle. Figure E, the next stitch should catch the new tape. 5. Stitch the new piece and overstitch the end a minimum of 1.25 inches or 3 stitches. Repeat with the outside row of stitches. Repair complete. Hidden patches. This type of repair has never had a name, but it is self-descriptive. It works well on tears and punctures. Done properly, it is a very cosmetic and cost-effective repair. 1. Take a piece of adhesive tape and place on the outside of the damaged area to hold the edges together. Figure F. 2. Turn the panel inside out, take the glue gun and glue a small piece of type 3 tape 1 inch longer over the damaged area. Figure G. Do not fold the ends under. Remove the adhesive tape from the outside. 3. Stitch around the outer perimeter of the type 3 tape using matching colored thread to the container fabric. If necessary, increase the upper thread tension so that the outside, bottom, thread shows good tension. 4. Take the zigzag machine, again with matching color thread, and set the stitch width to its widest setting and 7 to 11 SPI length. Overstitch the exposed edges of the cut area to draw them together. Figure H, repair complete. Overlay patches. These are similar to a fabric patch but use a piece of tape or webbing to cover the damaged area. In effect, it is the same as the hidden patch but usually larger and is on the outside of the panel. It is a sturdy patch but not very cosmetic. 1. Using a hot knife, cut a piece of tape or webbing, such as type 12, big enough to cover the damaged area. Allow enough to fold the cut ends under. Fold the ends under and glue down to itself. Figure I. 2. Lay the patch in place over the damaged area and mark the corners with a marking pencil. Figure J. 3. Take a straight pin and transfer the corners of the patch area through to the inside. Figure K. 4. If on a main container, take a piece of type 3 tape big enough to match the outside patches marked. Cover the inside of the damaged area with the tape. 5. Pin or glue the tape patch to the inside as marked. Use the single needle to sew around the patch, overstitching the ends a minimum of 1 inch. 6. Take the zigzag machine and stitch the edges of the damaged area together as described in Step 4, Hidden Patches. Figure L, repair complete. Single side fabric patches. For most fabric patches on a container panel, there is not enough area to perform a proper French fell seam patch. Consequently, the single side patch is the most common technique used. By using matching fabric and thread, a large damaged area may be covered to effect the necessary repair. While called a single side patch, in effect it is an enlarged version of the overlay patch. A smaller piece of webbing or fabric is used to cover the damaged area on the inside and the outside is covered with the single side patch. This technique is used where there may be large holes or widespread damage and replacement of the panel is not practical. 1. Duplicate steps 1 to 5 that was used in the overlay patches section above, but substitute webbing for the inside patch and use container fabric for the outside patch. 2. Fold the edges of the outside patch under a minimum of 0.5 inch. Stitch around the perimeter approximately 0.12 inch from the edge. Run a second row of stitches approximately 0.25 inch inside and parallel to the first. Figure M, this gives added strength to the patch and an appearance of a French fell seam patch. Repair complete. Inspection. Check thread tension, stitches per inch, and overstitch lengths. Damaged area must be covered completely. For the overlay and single side patches, make sure the stitch patterns catch both sides of the patch materials completely. Container grommet replacement. Applicable products, all types of containers that use grommets. Description: replacement of damaged grommets of all types, authorized repairman, FAA senior or master parachute rigger. Materials: E-thread, color to match, grommets, size, type, and material to match. Machines: 301 straight stitch, medium duty 7 to 11 SPI, 308 zigzag, medium duty 7 to 11 SPI. Equipment: scissors, seam ripper or scalpel, marking pencil, 6-inch ruler, grommet die set, size to match grommets, leather mallet, grommet cutting board, hole punch to match grommet size, basting tip, optional, and diagonal wire cutters, 8-inch minimum procedure. There are many types of grommets used in parachute container manufacture. Older style military surplus containers used flat grommets made of brass with a chrome finish, which were designed to work with cones. Most modern container systems use rolled rim spur grommets and washers. The most common size is the For many years, regular brass grommets were used and then nickel-plated ones became the norm. In recent years, stainless steel has come to be the preferred type due to the ability to resist deformation and corrosion. Today, there are two types of stainless grommets. The first is the regular or short shank. Recently, a long shank version has become available. It has proven to be very versatile and popular. This repair procedure focuses primarily on the spur grommet and washer, but the technique can be applied to all types of grommets. Disassembly, grommet replacement. This is for replacing a damaged grommet or changing from brass to stainless steel. Use the cutters to remove the grommet. If the grommet is set into a fabric/webbing base, fold the material back to expose the washer. Using the diagonal cutter, cut through the washer and then peel it back from the grommet. Figures A and B, grasp the grommet and peel it from the material. Reassembly, grommet replacement. If the hole is intact and undamaged, simply insert the replacement grommet into the material from the correct side, and set with the grommet die. Make sure that the grommet is set sufficiently so that there is no exposed edge to snag lines or material. Material repair and grommet replacement. If, after removing the grommet, the fabric is damaged so that the grommet cannot be set properly, use the zigzag machine to stitch around the perimeter of the hole, reducing its size. Figure C1. Take the basting tip and pass it through the hole, searing the material. Figure D. This solidifies the frayed and raw edge of the damaged material. 2. Set the grommet in the repaired hole. Figure E. Inspection. Check the grommet orientation. Grommet must be set tightly. There should be no sharp edges on inside of grommet. Container Velcro replacement. Applicable products. Most parachute assemblies that use Velcro. Description: main riser cover Velcro replacement. Authorized repairman, FAA senior or master parachute rigger. Materials: E-thread, color to match, Velcro color width and type to match. Machines: 301 straight stitch, medium duty 7 to 11 SPI. Equipment: scissors, seam ripper or scalpel, marking pencil, and 6-inch ruler. Procedure: the name Velcro is a trade name for what is known as pressure sensitive hook and loop fastener. It is a commonly used material for closure systems. Before the advent of Velcro, snaps and zippers were the preferred method of closing containers. Velcro changed how the parachute industry designed products. In the late 1970s and early 1980s, there was a tendency to overdo the use of Velcro, and problems with durability and interaction with other materials became known. Since then, the use of Velcro has been reduced to those applications where it is superior to other methods and can be easily replaced. Disassembly 1. Identify the nature of the use of the Velcro. Before you remove the piece, note how it is attached to the container. Some designs are such that several layers of construction have to be reversed to get to the location where the Velcro was sewn on. If this is the case, the rigger may have to make a very expensive repair to replace a small piece of Velcro. Reassembly 1. Cut the replacement Velcro to size. Velcro is normally scissor cut, not cut with a hot knife. 2. Position the Velcro and stitch around the perimeter at 0.12 inch from the edge. For any pieces, 1 inch in width or wider, sew a row of stitching down the center. Figure A. This prevents the center from being pulled up from the material and loading the outside row of stitching. Figure B. 3. Some applications have the Velcro sewn to a piece of tape for support. Again, if it is 1 inch or more wide, sew down the center to prevent lifting. 4. Depending on the application, the mating loop piece of Velcro may be wider than the hook to provide additional protection. That is, the hook may be 0.75 inch wide and the loop 1 inch wide. Inspection: check that thread tension is correct. Verify orientation is correct. Check that center stitching is used where needed. Container plastic stiffener replacement. Applicable products: all types of containers that use plastic stiffeners. Description: replacement of damaged plastic stiffeners of all types. Authorized repairman, FAA senior or master parachute rigger. Materials: E-thread, color to match, grommet size, type, and material to match, and plastic stiffeners, type and thickness to match. Machines: 301 straight stitch, medium duty 7 to 9 SPI and 308 zigzag, medium duty 7 to 11 SPI. Equipment: scissors, seam ripper or scalpel, marking pencil, 6-inch ruler, grommet die set, size to match grommets, leather mallet, grommet cutting board, hole punch to match grommet size, basting tip, diagonal wire cutters, 8-inch minimum, heavy shears or tin snips, electric drill and 3/8 inch drill bit, and feeler gauge, 0.010 inch. Procedure: the term plastic, when used in conjunction for the materials used as stiffeners in modern parachute containers, is a misnomer. In reality, the composition of the material varies. The most common material used today is maliddisulfide, MDS, nylon. In addition, Lexan, a clear polycarbonate material, and high-density polyethylene, HDPE, are also used. The most common thicknesses used are 0.025 inch, 0.040 inch, and 0.060 inch, which are standard commercial thicknesses commonly available. Stiffeners are used primarily as backing for grommets to spread the load placed on closing flaps. Instead of focusing the load on the diameter of the grommet, it is spread out across the length of the stiffener, resulting in a smoother flap and container. Consequently, replacing plastic stiffeners almost always requires replacing the grommet as well. Usually the plastic breaks at the grommet location because the hole for the grommet is the weak point. The following procedure shows the replacement of the bottom main flap stiffener of a Javelin container. Disassembly 1. Unpick the stitching that holds the binding tape to the bottom flap. Figure A, remove the grommet. 2. Remove the stitching that holds the stiffener in position. Remove the stiffener. Reassembly 1. Use the original stiffener as a template to cut a new stiffener. Figure B, while many of the older containers use HDPE or other materials, most of the newer designs use MDS nylon because of its superior properties. Because of this, many riggers use MDS exclusively for replacing any stiffeners. 2. Mark out the outline of the original stiffener on the MDS. Mark the center of the hole for the grommet very precisely. 3. Use the basting tip to mark the center of the hole for the grommet. Push the tip through the MDS until the shoulder of the tip makes an indentation in the MDS.
Figures C, D, and E. This forms a pilot hole for the drill.
4. Using heavy shears or tin snips, cut the MDS nylon to shape. Clip the corners to remove the sharp ends and, if the edges are sharp or rough, sand them with sandpaper. 5. Secure the MDS against a piece of wood and drill a 3/8 inch hole. While this hole may seem big for the shank of the grommet, when installed and the material is punched, it will be the right size. A common mistake is to make the hole too small, and when the grommet is set, it cracks the plastic. 6. Insert the stiffener in between the layers of fabric of the bottom flap and let it float inside. 7. Baste the 2 layers of fabric together with a single needle. 8. Restitch the binding to the bottom flap. Figure F, 9. Slide the stiffener to the edge of the flap and align the hole in the stiffener with the hole in the fabric. Use an O grommet to align the holes. Figure G, 10. Stitch the stiffener in place as per the original installation. 11. Insert the grommet with the correct orientation and set with the grommet set. Figure H, make sure that the grommet is set sufficiently so there is no exposed edge to snag the lines or material. Use the feeler gauge to check the gap under the edge of the grommet. Figure I, it should be no more than 0.010 inch. If more, hit the set again to tighten the grommet. Inspection, verify the stiffener backing is resewn. Check the grommet orientation. The grommet must be set tightly and measured. There should be no sharp edges on the inside of the grommet. Main container side flap replacement, applicable products, most modern container systems, description, replacement of a main container side flap, authorized repairman, FAA senior or master parachute rigger, materials, E-thread, color to match, type 3 3/4 inch tape, color to match, replacement flap, machines, 301 straight stitch, medium duty 5 to 9 SPI, 308 zigzag, medium duty 7 to 11 SPI, 301 double needle with tape folder 5 to 9 SPI, and 1 inch x 42 stitch bar tack, equipment, scissors, seam ripper or scalpel, marking pencil, 6 inch ruler, and hot knife procedure. The following technique is typical of many modern container systems. This procedure addresses only the disassembly of the container and replacement of the factory-made part. It does not address the manufacture of a replacement part. Disassembly 1. Remove all extraneous parts from the harness/container assembly. 2. Open the bottom corner of the main container on the appropriate side. 3. It is necessary to remove the Type 3 binding tape on the inside seam joining the main body to the side flap. Depending on the container construction configuration, there are 2 options how to do this. Option 1, Salvage Method. With this method, the binding tape is left undamaged and sewn back in place after replacing the flap. A slower method, but good if the rigger does not have the necessary replacement tape. Using a seam ripper, unpick the 2 rows of stitching that holds the side flap to the main container. Figure A, start at the lower corner and continue until approximately 2 inches past where the side flap joins the riser cover. Remove the side flap. Option 2, Replacement Tape Method. With this method, the binding tape is destroyed during the removal process and replaced with new. A faster method, but new tape is required. Use a hot knife to melt the stitching that holds the binding tape that attaches the side flap to the main container. Figure B, when doing this, have the side of the tape that faces the damaged side flap facing up in case you slip so the wrong flap is not damaged. Proceed to the point where the side flap stops. Trim the melted tape at this point. Using a seam ripper, unpick the tape approximately 2 inches past the end of the side flap. Remove the side flap. Reassembly 1. Take the new flap and sew it in place on the main container starting approximately 0.38 inch from the corner. Figure C, on this design and others like it, the lower end of the main riser cover is unstitched during removal of the main flap. When sewing the new flap in place, make sure that the side flap is sewn to the main container first and then the riser cover on top of it. Look at the opposite side to see which is on top and duplicate. 2. If option 1 was used, take the original binding tape, fold over the seam and sew in place with 2 rows of stitching. Note that there is a second row of stitching sewn directly on top of the inside row of stitching for reinforcement. Figure D, this is very important. 3. If option 2 was used, it is necessary to replace the binding tape with new. Stitch down the loose end of the binding tape at the top and then overlap the tape by approximately 2 inches using the double needle machine and tape binder. Figure E, overstitch the inside row for reinforcement. 4. Trim the bottom end of the binding tape at the corner. 5. Note that the junction of the side flap and riser cover is overstitched and reinforced as needed. Figure F. 6. Close the bottom of the container as per the original and reinforce as required. Inspection, check that the flap is installed correct side out. Check the inside binding for reinforcing stitching. The side flap/riser cover should be stitched and reinforced. The container bottom must be closed correctly and reinforced. Bottom of container, BOC, pocket replacement. Applicable products, any main container with a back pocket configuration, description, installation of a back pocket to the main container, authorized repairman, FAA senior or master parachute rigger, materials, E-thread, color to match, machines, 301 straight stitch, medium duty 7 to 9 SPI and 308 zigzag, medium duty 7 to 11 SPI, equipment, scissors, seam ripper or scalpel, marking pencil, and T-pins procedure. The following technique is typical of many modern container systems. This procedure addresses only the disassembly of the container and replacement of a factory-made replacement part. It does not address the manufacture of a replacement part. Depending on the size of the container assembly, it may be possible to do the replacement of the back pocket with the reserve packed. However, the smaller the system, the more difficult it will be. If the container cannot be placed under the machine, then remove the reserve canopy. Disassembly 1. Mark the location of the corners of the back pocket on the container with a marking pencil. 2. Open the lower right corner of the main container. Figure A. 3. Remove the old back pocket. Reassembly 1. Locate the new back pocket on the container at the marks of the old pocket and pin in place with T-pins. Figure B. 2. Stitch around the perimeter of the pocket with the single needle machine. Backstitch at the corners for reinforcing. Figure C. 3. Restitch the corner of the main container as per the original configuration. Inspection, check the orientation of the pocket with the opening to the right, unless for left-handed deployment. Check the stitching and corner reinforcing. Ring release housing replacement, applicable products, all harness and container systems equipped with a 3-ring release system. Description, replacement of damaged or missing 3-ring release housings, authorized repairman, FAA senior or master parachute rigger. Materials, nylon supertack, 3-ring housings of the correct length, heat shrink tubing, 1/2 inch diameter, owner's manual for the harness and container assembly, if available, machines, none, equipment, scissors, seam ripper or scalpel, marking pencil, 6-inch ruler, hand tacking needle, heat gun, crimping tool, optional. Procedure, replacement of the 3-ring housings may be necessary due to wear, damage, or stretching of the housings. Correct installation and tacking of the housings are important to ensure proper operation of the 3-ring release system. Disassembly 1. Inspect the original installation to determine the exact routing of the housings. Some systems have dedicated channels and/or loops through which they are routed. In others, the housings are routed under or over back straps or reserve ripcord housings. If necessary, draw a diagram of the routing or take a picture so that the replacement housings are routed correctly. 2. Remove any tackings or clamps that hold the housings together and/or to the container. Remove the housings from the system. Reassembly 1. Install the replacement housings into their respective locations as per the original installation. Usually the longer housing is installed first and then the shorter one. 2. Make sure that the flat side of the housing terminal end is orientated outward so that it lays flat against the rear of the main riser when the 3-ring release is assembled correctly. Figure A.3. Align the handle end of the housings and secure as per the original installation. This may be with either a double clamp or hand tacking. Figure B. Figure C shows a typical method of using super tack to secure the housings together. 4. If hand tacking is used, it is desirable to cover the tacking with heat shrink tubing. Place a length of tubing over the housing ends and shrink using the heat gun. Figure D. 5. Secure the double housing to the container/back pad or pocket assembly. Depending on the manufacturer, it may be necessary to provide a certain amount of float to the housings in order that the loop of the riser is not loaded or under tension when the main canopy is deployed. If available, consult the owner's manual for correct positioning and tacking. Some systems use a double clamp to secure the housings together, as well as to the container or pockets. If these are used, inspect the clamp to make sure that it was not damaged when removing the housings and can be reused. Crimp the housings, making sure that the clamp is tight so the housings cannot work loose. Figure E6. Route the release cables through the housings to make sure there are no obstructions. Inspection, check for correct routing of the housings. Verify correct orientation of the terminal ends. Housings should be secured together at the handle ends. Housings should be secured to the container/back pad or pockets with either clamps or super tack. There should be sufficient slack or float in the housings. Housings should be clear. Section 3, Harness and risers. Harness repairs are almost always a major repair. Consequently, they are master rigger work. About the only repairs open to a senior rigger are replacement of ripcord pockets and Velcro, and replacement of hand tackings for ripcords, comfort pads, 3-ring housings, and other hardware. Major harness repairs are the most critical maintenance operations a rigger can perform on a parachute assembly. Even seemingly innocuous repairs, if done incorrectly, can have fatal consequences. Depending on the type of harness design, repairs to the harness main lift web or leg straps involve major repair or remanufacture. According to 14 CFR Part 65, Section 65.129, E and F, no certificated parachute rigger may, pack, maintain or alter a parachute in any manner that deviates from procedures approved by the administrator or the manufacturer of the parachute, or, F, exercise the privileges of his certificate and type rating unless he understands the current manufacturer's instructions for the operation involved. In other words, because this operation is a major repair, the person doing the work must be a currently certificated master parachute rigger with the appropriate ratings. In the past, many master riggers felt that they were empowered to undertake almost any task. The attitude was, we can lift the TSO label, build a new harness, and put the TSO label back on. This is not the case. Just because an individual has a master rigger license does not mean he or she is qualified to undertake a complex repair. There are 4 primary areas of concern that need to be addressed in any repair program. They are as follows: 1. Inspection, damage identification, and repair planning. 2. Tear down and clean up. 3. Preparation and reconstruction. 4. Quality control, inspection and record keeping. Main risers are components that are subject to extreme wear and tear. The only items that are practical for repair are the 3-ring locking loops and the toggle mounting/Velcro assembly. Once the webbing begins to show wear, it is more practical to replace than repair them. The following are repairs found in Section 3, Harness and risers: chest strap replacement, lower leg strap shortening, ripcord pocket Velcro replacement, articulated upper leg hardware replacement, standard harness main lift web replacement, main riser 3-ring locking loop replacement, main riser steering toggle Velcro replacement, chest strap replacement. Applicable products: most standard harness configurations. Description: replacement of chest strap due to damage or for lengthening. Authorized repairman, FAA master parachute rigger. Materials: E-thread, 5-cord nylon thread. Machines: 301 straight stitch, medium duty 7 to 11 SPI, heavy duty harness machine, Singer 7 to 33 or equivalent stitch length to match the original, and 308 zigzag, medium duty 7 to 11 SPI. Equipment: scissors, seam ripper or scalpel, marking pencil, ruler, hot glue gun, and hot knife. Procedure: this procedure deals with the longer side of the chest strap, usually the left, which is threaded through the chest adapter or through an adjustable V-ring. Replacing the opposite side would mirror this process. Disassembly. 1. Examine the chest strap/MLW junction to determine if the back pad needs to be removed from the harness to access the junction. If so, remove the pad from the harness to allow access to the junction. Figure A2. Many harnesses have the reserve ripcord housing located on the left side. The housing needs to be disconnected at this location. It is usually secured to a loop located at the chest strap junction. During the replacement process, this loop is removed and may be reused if in good condition. 3. Remove the harness stitching and any other stitching from the junction, making sure not to damage the main lift web. Figure B. 4. Remove the old chest strap webbing from the main lift web. Pay particular attention to the end of the webbing. While most chest straps are installed at right angles to the main lift web, some have an angle cut at the end for better fit. If the webbing has an angle, make sure to duplicate it. 5. Clean the junction area of old thread, as well as any glue residue on the inside of the main lift web. 6. Take the marking pencil and mark the points of the stitch pattern for the reassembly. Figure C. Most chest straps are installed with a 3-point WW in a horizontal orientation, but the rigger should duplicate the original design. 7. If the procedure is a replacement of a damaged chest strap, then it should be replaced to the original length. If so, then remove the rolled stop end so that the finished length may be determined. If the chest strap is to be lengthened, then an appropriate length of webbing needs to be determined. The finished length should be measured from the outside of the main lift web plus 3.50 inches. Figure D, Reassembly 1. Cut a piece of webbing to the appropriate length. If needed, cut the MLW end of the strap at an angle. Figure E2. Insert the end of the webbing into the MLW junction. Align the end of the chest strap with the outside edge of the MLW. Insert the housing loop back into the junction as well. Lightly glue the MLW to the chest strap. Figure F, do not use too much glue. 3. Some harnesses are pre-sewn along the edges with a medium-duty machine and E-thread. If so, duplicate this. 4. Using the harness machine and 5-cord nylon thread, so the junction is marked with the original pattern. Figure G5. Mark the length of the chest strap to include enough needed for the stop end. If the chest strap is to be configured for a thread-through adapter, an additional 3.50 inches is needed for the rollback. 6. After determining the cut length, place a mark at 3.50 inches on the backside of the chest strap. Fold to this mark and then fold the webbing one more time for 3 layers. Figures H and I7. Using the zigzag machine, sew across the center of the stop end fold. This results in a loose fold that jams against the adapter in the event of slippage of the chest strap. Figure J8. If the MLW is attached to the backpad assembly, reattach as per the original configuration. If the backpad is attached in such a manner that does not allow inspection of the back side of the MLW, inspect the stitching at this time before reattaching the backpad. 9. Reinstall the ripcord housing and secure. Inspection. Inspect the harness stitching for correct stitch length, tension, and appropriate pattern. Reattach the MLW to the backpad as needed. The stop end must be sewn and oriented correctly. Verify the chest strap is the correct length. The ripcord housing must be reinstalled and tacked. Lower leg strap shortening, applicable products, all harness configurations description, shortening of the lower leg straps, authorized repairman, FAA master parachute rigger, materials, 5-cord nylon thread, color to match original machines, heavy-duty harness machine, Singer 7-33 or equivalent 5-7 SPI, equipment, seam ripper or scalpel, marking pencil, ruler, and hot knife procedure. The shortening of the leg strap, while a relatively straightforward process, is an extremely important procedure. If done improperly, it could result in the harness fitting improperly or the leg straps to come unthreaded and the user to fall out during opening. Disassembly 1. If the leg strap is of the thread-through configuration, unthread the webbing from the leg adapter. If the leg strap has an adjustable V-ring used in conjunction with a snap, disconnect the V-ring from the snap. Lay the leg strap out flat. 2. Remove the harness stitching from the rolled end of the webbing. 3. Measure the required distance from the end of the strap that is required for shortening and mark accordingly. Figure A. 4. Trim the webbing at the mark using the hot knife. Reassembly 1. For the thread-through configuration, place a mark at 3.50 inches from the end of the webbing on the bottom of the webbing. Figure B. This is the fold to mark for the first fold of the webbing. Fold one more time for a total of 3 layers of webbing. Figure C2. Sew the rolled stop end according to Figure D with the harness machine. 3. For the V-ring configuration, place a mark at 2 inches from the top end of the webbing. This is also the fold to mark for the first fold. Make 2 additional folds for a total of 4 layers. 4. Sew the rolled stop end according to Figure E with the harness machine. Inspection. Check the stitching for the correct pattern and thread tension. For the thread-through configuration, Make sure there is no twist to the leg strap and thread the webbing through the leg adapter. The rolled end should face outward. For the V-ring configuration, connect the V-ring to the snap. The rolled stop end should also face outward. Ripcord pocket Velcro replacement, applicable products, any harness configuration with a Velcro style ripcord pocket configuration, description, replacement of the Velcro of the ripcord pocket, authorized repairman, FAA senior or master parachute rigger, materials, E-thread, color to match original, hook and loop Velcro width and length to match original, machines, 301 straight stitch, medium duty 7 to 11 SPI and 308 zigzag, medium duty 7 to 11 SPI, equipment, scissors, seam ripper or scalpel, marking pencil, 6-inch ruler, and glue gun. Procedure disassembly 1. Depending on the configuration, it may be necessary to remove the ripcord housing from its attachment point on the harness for access to the pocket. If the harness is attached to the back pad, disconnect this as well. 2. Remove the E-thread stitch pattern that forms the pocket on the MLW. Figure A. 3. Mark the ends of the old Velcro and remove from the inside of the webbing. Note which side of the webbing the hook and loop are located. Reassembly 1. Cut the replacement Velcro to the correct length. 2. Glue the Velcro pieces to their respective locations on the inside of the webbing. 3. Using the single needle machine, sew around the perimeter of the Velcro, as well as a row of stitching down the center. Figure B. Repeat for the opposite side. 4. Re-sew the pocket with 2 rows of single needle stitching with E-thread. Figure C. 5. Reattach the harness to the back pad. 6. Reinstall the ripcord housing to the harness. Inspection. Verify the correct orientation of the Velcro in the pocket. The correct stitch pattern must be used for the Velcro. Verify the ripcord pocket is re-sewn. The back pad must be reattached, if needed. The ripcord housing must be reinstalled. Articulated upper leg hardware replacement, applicable products, most articulated harness configurations. Description, replacement of the upper leg strap hardware, authorized repairman, FAA master parachute rigger, materials, E-thread, color to match, 5-cord nylon thread, color to match, type 8 webbing, color to match, type 12 webbing, type 4 1-inch tape, replacement adapter, MS-20 2040, machines, 301 straight stitch, medium duty 7 to 11 SPI, 308 zigzag, medium duty 7 to 11 SPI, heavy duty harness machine, Singer 7 to 33 or equivalent, stitch to match the original, equipment, scissors, seam ripper or scalpel, marking pencil, ruler, glue gun, and 4-point WW pattern template procedure. The following procedure is required when the knurling on the friction bar has worn to the point that the leg strap would slip on opening. In addition, the webbing at the ring location shows where it is replaced at the same time. This procedure is typical for a flex-on and Talon 2 articulated harness configuration. Disassembly 1. Remove the leg pad assembly. 2. Remove the leg strap by cutting the webbing. Reassembly 1. Use figure A to cut a replacement leg strap in parts. 2. Take the tie 8 webbing and sew a bow tie fold with the tie 4 tape buffer at the 3.50-inch mark. Figure B. 3. Turn the adapter upside down and install the tie 8 webbing as shown and glue in place. Figure C. 4. Install the bow tie around the ring and glue in place. Figure D. The picture shows the inside orientation of the harness. 5. Double check the correct orientation of the hardware. Figure E. 6. Mark the stitch pattern. Figure F. 7. Sew the webbing with the harness machine in a 4-point WW pattern. Figure G. 8. Reinstall the leg pad. Route the upper pad flap through the adapter from the bottom and zigzag. Figure H. 9. Fold the bottom pad under and zigzag in place. Figure I. Note that the ends of the upper and lower pads are offset to reduce the thickness to be sewn. Inspection. Verify the hardware orientation is correct. Verify the stitch pattern is correct. The leg pad must be reinstalled correctly. Standard harness main lift web replacement, applicable products, most standard harness configurations. Description, complete replacement of one side of a standard harness main lift web, authorized repairman, FAA master parachute rigger. Materials, E-thread, color to match, 5-cord nylon thread, color to match, type 7 webbing, color to match, type 8 webbing, color to match, type 12 webbing, color to match, machines, 301 straight stitch, medium duty 7 to 11 SPI, 308 zigzag, medium duty 7 to 11 SPI, and heavy duty harness machine, Singer 7 to 33 or equivalent 5 to 7 SPI, equipment, hot knife and cutting glass, hot glue gun, measuring rulers, 6, 18, and 36 inch, sewing pattern templates, marking pencils, scissors and thread snips, X-Acto knife or scalpel, hemostats, type 4 1-inch tape, color to match, type 3 tape, color to match, 1.5-inch Velcro hook and loop, and 1-inch Velcro hook and loop background. The following steps provide an overview of the procedure to follow. Step 1. The first thing the rigger must do is to inspect the parachute harness to identify the make and model and determine the extent of the damage. In some cases, particularly for older designs, it may not be practical or economically feasible to repair the harness. If the rigger determines that repair is practical, he or she must then establish a repair plan for the project. There are two reasons for this: 1, that the project is done logically and efficiently, and 2, if not having done this type of repair before, having contacted the manufacturer for guidance, the rigger can explain what he or she intends to do to effect the repair. The rigger must make detailed measurements of the harness. Figure A shows a typical harness configuration and the needed dimensions. On a situation where one side of the harness is intact and can be used for reference, the rigger still needs dimensions to work against to determine how much material to order or bill to the job. If both sides of the harness are damaged, great care must be taken to ensure the correct measurements of the final repair. Step 2. Teardown and cleanup is the second most important part of the process. It is important that all the old thread, glue, and damaged webbing are removed. Leaving any of these in place and sewing over them results in a poor appearance. Also, it is not uncommon to find additional damage or wear at this point that was not identified during the initial inspection process. Step 3. After the teardown and cleanup, the replacement webbing can be measured, cut, and pre-sewn in preparation for installation to the harness assembly. The construction sequence is followed. In certain cases, it may be desirable to replace not just damaged parts but worn ones to give the final result a more cosmetic appearance. An example is when replacing a main lift web. It does not look good to reuse the old chest strap webbing when the main lift web is new material. Step 4. After the repair is completed, a thorough quality control program is undertaken. This is especially critical in a situation where the rigger is working alone and there is no one to rely on for cross-checking the work. All the critical points of the repair must be identified and checked, as well as the finished dimensions. Procedure: Disassembly 1. Remove all housings, leg pads, and any other parts that may interfere with the work from the harness. Disassemble the leg strap/horizontal back strap junction. Figure B. Disconnect the upper MLW from the yoke portion of the back pad if necessary. 2. Disassemble the junction of the diagonal back strap and main lift web at the 3-ring attachment point. Figure C. Be very careful not to damage the diagonal back strap. If it is damaged, it is a major project to replace this on most assemblies. 3. Lay out the main lift web assembly and check the measurements against the initial dimensions. Check against the opposite side MLW for symmetry. 4. If this side of the harness has a TSO or identification label attached, carefully remove it for use on the new assembly. If it is damaged, it may be necessary to get a new label to replace it. Contact the manufacturer for guidance. They may require the rigger to return the old label in exchange for a new one. Reassembly 1. Note that this configuration consists primarily of two main pieces of webbing. The front MLW is type 7 webbing and the rear is type 8. 2. Measure the new webbing for the main lift webs. Add 5 inches for the riser end fold back and allow at least 6 inches extra for shrinkage. While this may sound like a lot, nothing is more discouraging than to get to the end of the project and find that the webbing is short by an inch or two. A couple inches of scrap is a small price to pay at this point. 3. Starting at one end of the webbing, measure the riser end configuration. Fold back and glue in place. If there is a toggle stow loop on the old harness, do not forget to glue in place before sewing. Figure D. Mark the 4-point WW pattern and sew with the harness machine and 5-cord nylon thread. 4. Install the steering line guide ring with a duplicate stitch pattern as per the original. Figure E. In some instances, the manufacturer may have used a special bar tack or other stitch pattern to attach the ring. If the rigger does not have the same machine, it is necessary to contact the manufacturer for an acceptable alternative. This should have been identified in Phase 1. Check the distance from the end of the riser to the top of the ring. The industry standard is 4 inches, but there may be special dimensions for some applications. 5. Install the toggle Velcro keepers as per the original. Figure F. Complete any other sewing needed, such as the end of the toggle stow loop. 6. If needed, reattach the TSO label at the appropriate location. If the label is the original one and is made from materials such as Tyvek, try to follow the original needle holes to avoid perforating the material. Too many holes cause the label to tear out. 7. Working from the measurement diagram in Figure A, mark the location of the 3-ring. 8. Working downward, mark the location of the chest strap, the ripcord pocket, and the bottom of the upper leg strap. Figure G, note, it is necessary to allow for a certain amount of shrinkage during the sewing process. There are 4 areas of shrinkage to allow for. 1. The harness stitching at the 3-ring. 2. The harness stitching at the chest strap. 3. The ripcord pocket. 4. The harness stitching at the leg strap junction. The standard rule of thumb for the sum of these patterns is approximately 0.75 inch for the length. In other words, the marked length of the MLW should be 0.75 inch longer than the desired finished length. Most of the shrinkage is in the ripcord pocket and the leg strap junction. If the rigger has not done this operation before, he or she may want to build a sample MLW to check the measurements and the resultant shrinkage. 9. Sew the Velcro in place for the ripcord pocket. Figure H, 10. Glue the chest strap in place. In this instance, do not forget the housing loop. 11. Using the single needle, pre-sew the front and rear main lift webs. Use of the sewing pattern in Figure I accomplishes this and at the same time creates the ripcord pocket. Sew the chest strap 3.WW with the harness machine. Figure J, 12. Reassemble the upper diagonal back strap and the 3-ring hardware by threading the rear riser through the large ring followed by the front riser. 13. Position the 3-ring at the mark on the main lift web and glue in place. Install the Type 12 confluence wrap below the 3-ring and mark the 4.WW pattern. Figure K, 14. Sew the confluence wrap with the harness machine. Figure L, 15. Recreate the leg junction. Glue the upper leg strap in place first and then the horizontal back strap second. Figure M. 16. Mark the 4.WW and then sew with the harness machine. Start the stitch pattern at the front side of the MLW and complete with the overstitch the full length of the pattern. Figure N, this provides additional reinforcing at the upper leg strap/MLW location. 17. Measure the length of the lower leg strap allowing 3.50 inches for the rolled stop end. Trim to length and then install the stop end with the harness machine. 18. Reattach the back pad to the upper MLW using the 308 zigzag machine. 19. Reinstall the leg pads using the 308 zigzag machine. 20. Reinstall the ripcord and 3-ring housings and hand tack in place. Inspection: check the finished dimensions against the original dimensions in Figure A. If only one side has been replaced, check the new MLW against the opposite side for comparison. The generally accepted tolerances for this type of construction are plus or minus 0.25 inch. In particular, reserve riser length and the overall MLW length are the most important. If either of these is mismatched to their opposites, then the flight of the canopies may be affected. Start inspecting from the riser end working down. Use the inspection chart in Figure O as a guide for the inspection points. After the inspection, all appropriate paperwork must be completed. This includes the rigger's logbook, the packing data card for the parachute, and any shop or business forms or log. Main riser 3-ring locking loop replacement, applicable products, all 3-ring riser assemblies, description, replacement of the 3-ring riser locking loop, authorized repairman, FAA senior or master parachute rigger, materials, E-thread, 5-cord nylon thread, color to match, Type E nylon cord or equivalent, machines, 308 zigzag, medium duty 10 SPI and heavy duty harness machine, Singer 7-33 or equivalent equipment, scissors, seam ripper or scalpel, marking pencil, 6-inch ruler, glue gun, and hot knife. Procedure: disassembly: mark the locking loop at the bottom edge of the confluence wrap. Figure A: place a mark at the bottom of the confluence wrap and carefully remove the confluence wrap from the riser. Remove the old locking loop. Reassembly 1. Cut a new loop the length of the old one plus 2 inches. 2. Fold the new loop in half and lay alongside the old loop. Transfer the marks from the old loop to the new one. Figure B, 3. Align the marks on the loop with the mark at the bottom of the confluence wrap on the riser. Figure C, glue the loop in place. 4. Sew the loop with the 308 zigzag machine. Figure D, set the stitch width at approximately 1/8 inch and 10 SPI. 5. Trim the excess loop off at the top. Figure E, 6. Reinstall the confluence wrap using the harness machine. Figure F. Inspection: before installing the confluence wrap, make sure the zigzag stitching is complete. The loop length should be the same as the old loop. The confluence wrap must be reinstalled. Main riser steering toggle Velcro replacement, Applicable products. Most main risers with a Velcro toggle installation. Description: replacement of the Velcro toggle keeper on main risers. Authorized repairman, FAA senior or master parachute rigger. Materials: E-thread, Velcro of the appropriate width and type. Machines: 301 straight stitch, medium duty 7 to 11 SPI. Equipment: scissors, seam ripper or scalpel, marking pencil, and 6-inch ruler. Procedure: the term Velcro is used in a generic fashion for hook and loop fastener, while the rigger should replace the Velcro to match the original configuration. This installation has proven superior for its holding ability and the secure line stow configuration. Disassembly 1. Mark the location of the old Velcro. Figure A2. Remove the old Velcro. Reassembly 1. Cut anew pieces of Velcro to match the original. 2. Position the Velcro to the original location. 3. Sew the hook Velcro with a single needle machine. Sew an additional row of stitching down the center of the Velcro. Figure B. This keeps the center from lifting during use and tearing out the edge stitching. 4. Position the loop line stow Velcro to match the hook and sew along the edge, overstitching the ends. Figure C. Inspection. Check that the location of Velcro is the same as the original. Check stitch patterns and center stitching. Section 4. Accessory components. Accessory components are comprised of the reserve pilot chute, reserve deployment bag or device, main deployment bag, main pilot chute and bridle, main and reserve toggles, reserve static line, RSL lanyard, 3-ring release handle, and reserve ripcord. The reserve components generally do not suffer much wear due to their infrequent use. In addition, with their frequent inspection during the repack cycle, any necessary repairs become obvious and are taken care of before they become major problems. 1. Metal ripcords usually are not repairable and must be replaced when they are damaged. 2. Reserve pilot chutes experience torn mesh, minor canopy damage, broken hand tackings, and damaged grommets in the cap. The reserve free bag may have the grommets in the closing flap pull out of the material. The high drag bridle is a critical area and is usually not repairable. The RSL lanyard is another critical item that is usually not repairable, except for the replacement of a defective snap shackle. Main components, on the other hand, are subject to extensive wear and tear. Most jumpers do not take time to inspect their main components on a regular basis and generally operate on a repair as broken basis. By the time the rigger sees the components, it is easier and more cost-effective to replace than to repair them. However, there are regular wear trends that the rigger can make their customers aware of so they can look for them and have them taken care of. The following are repairs to accessory components, found in Section 4, Accessory Components, of this chapter. Reserve pilot chute repair, mesh, tackings, and bag grommet, reserve free bag repair, grommet pullout, main pilot chute repair, top canopy reinforcing, main pilot chute collapsible bridle replacement, main deployment bag repair, closing flap grommet pullout, reserve pilot chute repair, mesh, tackings, and bag grommet. Applicable products: most reserve pilot chutes. Description: replacement of cap grommet, authorized repairman, FAA master parachute rigger. Materials: nylon supertack, stainless steel sheet grommet, same as original. Machines: none. Equipment: scissors, seam ripper or scalpel, hand tacking needle, grommet set, and diagonal cutters. Procedure: the canopy fabric portion of a reserve pilot chute would be repaired as necessary with similar patching techniques as used on a canopy. The mesh portion, however, may be subject to different techniques. Another area of common damage is the through grommet in the top of the pilot chute. The following procedure describes the replacement of the grommet in the top of the pilot chute. Figure A shows a damaged grommet. Disassembly 1. Remove the hand tackings used to secure the base of the pilot chute to the spring. Figure B. Turn the pilot chute upside down and push the canopy down until the grommet is exposed. Figure C3. Using diagonal cutters, remove the damaged grommet, being careful not to damage the fabric of the cap. Figure D. Reassembly 1. Using the handset, set a new grommet. Be careful not to catch any fabric during the process. Figure E2. Reposition the canopy over the spring. Grasp the skirt at the bottom end of the spring. Make sure that the radial tapes run directly from the bottom to the cap in a straight line. Figure F. If the tapes barber pull around the spring, the pilot chute may not inflate properly on launch. 3. Hand tack the bottom of the canopy to the bottom of the spring. Figure G. Inspection. Verify the grommet is secure. Tapes should be straight. Tacking should be secure. Disassembly, mesh repair 1. Remove the tackings used to secure the base of the pilot chute to the spring. 2. For small holes, turn the mesh inside out and zigzag the edges together. Reassembly 1. Reattach the bottom of the pilot chute to the spring with hand tacking. Inspection, tapes should be straight. Tacking should be secure. Reserve-free bag repair, grommet pullout, applicable products. Most reserve-free bags. Description, general repair to the reserve-free bag, authorized repairman, FAA master parachute rigger, materials, E-thread, 1.5-inch type 3 tape, and grommets to match the original type and size, machines, 301 straight stitch, medium duty 7 to 11 SPI, equipment, scissors, seam ripper or scalpel, marking pencil, 6-inch ruler, hot knife, grommet set, and hole punch procedure. Most reserve-free bag designs are fairly robust. The most common types of damage seen are the pulling out of the grommets in the tongue of the bag and tearing out of fabric from the binding tape due to overstressing during packing. Figure A, damage to the bridle portion of the free bag is generally not repairable nor allowed by most manufacturers. Consequently, any damage in this area would necessitate the replacement of the bag. The following procedure deals with the repair of the tongue area and replacement of the grommets. Disassembly 1. Remove the grommets from the tongue. Figure B. Remove the binding from the tongue area by unpicking the stitching. Figure C, Reassembly 1. Cut 2 pieces of 1.5-inch type 3 tape and overlay them on each side of the damaged area. Sew around the edges of the tape and down the center to secure it. Figure D. 2. Trim the ends of the tape to match the shape of the tongue. 3. Using the single needle machine, reapply the binding tape around the edge of the tongue. Figure E4. Punch new holes over the exact position as the original ones. Figure F5. Insert new grommets. Figure G. Inspection. Reinforcing tape must be secure. Binding must be resewn. Grommets must be set and secure. Main pilot chute repair, top canopy reinforcing, applicable products, most main hand deploy pilot chutes. Description, repair of the apex area of a hand deploy pilot chute, authorized repairman, FAA senior or master parachute rigger, materials, E-thread and 3/4-inch type 3 tape, machines, 301 straight stitch, medium duty 7 to 11 SPI, equipment, scissors, seam ripper or scalpel, marking pencil, 6-inch ruler, and hot knife procedure. Most repairs of the main pilot chute consist of fabric or mesh repairs and may be repaired similar to canopy procedures. The most common damage seen on main pilot chutes is in the area of the apex and the hand deploy handle. Figure A, this area is subject to fairly severe stress and strain. The following procedure deals with the apex area repair. It should be noted that if the repair is too complex, it is probably more cost-effective to replace rather than repair the pilot chute. Disassembly 1. Working through the hole in the base, turn the pilot chute inside out. Unpick the seam at the junction of the canopy and mesh in between 2 of the radial tapes. Figure B, this allows good access to the apex area. Reassembly 1. Take a piece of 3/4-inch type 3 tape and overlay the reinforcing material at the apex, covering the damaged area. Figure C2. Re-sew the canopy and mesh panels as per the original. Turn the pilot chute right side out. Inspection, damaged area must be covered. Canopy seam must be re-stitched correctly. Main pilot chute collapsible bridle replacement, applicable products, most kill line pilot chute bridle configurations. Description, replacement of the bridle of a kill line collapsible pilot chute, authorized repairman, FAA senior or master parachute rigger, materials, E-thread, replacement bridle, machines, 301 straight stitch, medium duty 7 to 11 SPI and 1-inch x 42 stitch bar tack 308 zigzag, medium duty 7 to 11 SPI, optional equipment, scissors, seam ripper or scalpel, green felt tip marker, 6-inch ruler, hemostats, pony clamp, and hot glue gun procedure. There are 3 basic main bridle configurations listed below. Standard non-collapsible bridle, bungee collapsible bridle, centerline or kill line collapsible bridle. The standard bridle is a simple design and any damage usually results in the replacement of the bridle. The exception to this is if the tape attaching the curved pin is worn. The replacement of the tape is a simple task. The most common bridle in use today is the kill line collapsible type. The replacement of the bridle is described in the following procedure. Disassembly 1. Remove the old bridle from the pilot chute. Figure A, Reassembly 1. Thread the loop ends of the bridle through the bottom support tapes of the pilot chute. Figure B. Glue the ends in place with the glue gun. Figure C3. Bar tack the bridle along the sides. Do not capture the center line. Figure D4. Align the bridle tapes on the center of the pilot chute attachment tapes and bar tack in place. Figure E5. Check the trim of the pilot chute center line. When the center line is taut, The apex should be even with or no more than 1 inch below the skirt of the canopy. 6. Anchor the bag end of the pilot chute at the bag stop. Grasp the spectra centerline and pull to cock the bridle. 7. Route the free end of the spectra centerline up through the center of the pilot chute and through the loop of the pilot chute centerline at the apex. Grasp the handle of the pilot chute and apply tension so that the centerline of the pilot chute and the bridle are equal. Pinch the spectra line so that the location will not move. Secure with 2 half hitches. Figure F, 8. Change the anchor point to the end of the bridle. Stretch the bridle so that the pilot chute is collapsed. Lay the pilot chute out with the mesh exposed and secure the radial tapes with the pony clamp at the mesh/fabric seam. Figure G, pull moderate tension on the pony clamp and check the location of the apex of the pilot chute at the opening of the bridle. 9. Again anchor the bridle at the bag stop and cock the bridle. Check the position of the apex of the pilot chute. It should be within 1 inch of the skirt. Figure H, 10. Finger trap the running end of the spectra centerline for a distance of 3 inches. Figure I, bar tack or zigzag to secure. Trim the excess line. 11. Cock the bridle. Take the hemostats and grasp the spectra centerline at the eye of the bridle. Figure J, 12. Pull the centerline out to expose approximately 3 inches each side of the hemostats. Take the green felt tip marker and place a mark at the hemostat location and 1 inch either side. Figure K, color the line between the marks and on both sides. Figure L, 13. Pull the bridle tight to reposition the centerline and check the green color of the eye. Figure M, inspection, check the bar tack at the pilot chute loops and at the base. Verify the spectra centerline is knotted, finger trapped and sewn. Verify the colored eye location of the centerline is marked green. Main deployment bag repair, closing flap grommet pullout, applicable products, all main deployment bags, description, repair of main deployment bag, authorized repairman, FAA senior or master parachute rigger, materials, E-thread, type 4 tape or equivalent and grommets to match original machines, 301 straight stitch, medium duty 7 to 11 SPI and 308 zigzag, medium duty 7 to 11 SPI, equipment scissors, seam ripper or scalpel, marking pencil, 6-inch ruler, grommet set, and hole punch procedure. The most common repair needed to a main deployment is the repair of the closing flap in the area of the grommets. The grommets work loose and pull out, damaging the material. The tongue will need reinforcing and new grommets. Disassembly 1. Remove grommets from the tongue of the bag. 2. Unpick the binding along the edge of the grommet reinforcing tape. Figure A, reassembly 1. Overlay a piece of 1.5-inch type 4 tape on the top of the bag tongue and sew down. Figure B. Punch new holes through the type 4 from the back side in the same location as the original location. 3. Overlay the back side of the tongue with a piece of 1.5-inch type 3 tape and sew down. Figure C. Punch new holes through the tape. 5. Set new grommets in the original locations. Figure E. Inspection. Verify stitching is secure. Verify new grommets are secure. Section 5. Alterations. In the old days when military surplus equipment was common, there were a number of alterations available to make the surplus equipment suitable for sport use. Since then, however, the sport has progressed and purpose-built sport equipment is now the rule, so most equipment does not need any specialized alterations for use. Most alterations now deal primarily with harness size adjustments for individuals, or they are designed to enhance the performance of the parachute. In the past, alterations were often done by well-intentioned individuals who knew how to do them but in most cases did not have the authority to perform them. The common attitude was, "I'm a master rigger, I can do anything." As long as the work was done reasonably well and no one got hurt, this was an accepted practice. While there may be a few individuals who still adhere to that philosophy, as a whole, the rigging profession is much more aware of limitations in regard to alterations. Under 14 CFR Part 65, Section 65.129d, no certificated parachute rigger may, d, alter a parachute in a manner that is not specifically authorized by the administrator or the manufacturer. In today's world, manufacturers are much more concerned with the alterations being performed on their products. With the advent of the internet and other means of high-speed communications, riggers have much more access to the manufacturer and are more likely to communicate with them as to what can be done. Also, due to liability issues, many riggers are reluctant to undertake alterations without the manufacturer's approval. What constitutes the manufacturer's approval for an alteration? To be safe, the rigger should always have something in writing that specifically addresses the alteration the rigger wishes to perform. There should be a two-way line of communication for this. 1. the rigger should specifically request from the manufacturer the authority to perform the alteration. This should include serial number, make, model of the product involved, and a description of the alteration. 2. In return, the rigger should receive written authorization to perform the alteration. The manufacturer specifies the form of this authorization, but it should have the date, the rigger's name and certificate number, and a reference to the rigger's original request. This fulfills the requirements of the regulations and protects both parties involved. In certain cases, a rigger might want to perform an alteration on a product for which the manufacturer is no longer in business. This is commonly known as an orphan product. If this occurs, the rigger should obtain approval from the FAA. Refer to AC 105-2, Sport Parachute Jumping. Alterations to approved parachutes must be performed only by a certificated and appropriately rated master parachute rigger, a parachute manufacturer, or any other manufacturer that the FAA considers competent. To receive approval from the FAA, a person qualified to alter a parachute would first contact the FAA Flight Standards District Office, FSDO, to discuss the proposed alteration with an FAA inspector. The inspector requires a description of the proposed alteration along with a sample, technical data and proposed test data to ensure that the altered parachute meets all applicable requirements. After discussing the proposed alteration, the two parties agree on a suitable plan of action. The individual then drafts an application, in letter form, addressed to the local FSDO. Along with a letter, the following information needs to be attached. 1. A clear description of the alteration. 2. Technical information that includes drawings and photographs, materials used, stitch patterns, and location of altered components. 3. A means of identifying the altered parachute, such as model and serial number, and identification of the person having performed the alteration after the inspector reviews the application. If he or she is satisfied, he or she indicates approval by date stamping, signing, and placing the FSDO identification stamp on the letter of application. Upon receiving this approval, the master rigger can then perform the alteration. The following are alterations found in Section 5, Alterations, of this chapter. Articulated harness main lift web resizing, leg pad resizing, automatic activation device, AAD installation note. A denotes approval needed by the administrator or the manufacturer. Articulated harness main lift web, MLW resizing, applicable products, most articulated harness configurations, description, resizing of an articulated harness, authorized repairman, FAA master parachute rigger, materials, E-thread, 5-cord nylon thread, Type 7 webbing, or as original and Type 4 1-inch tape. Machines, 308 zigzag, medium duty 7 to 11 SPI, heavy duty harness machine, Singer 7 to 33 or equivalent 4 to 6 SPI, equipment, scissors, seam ripper or scalpel, marking pencil, 18-inch ruler, and hot glue gun. Procedure resizing of a harness is usually considered an alteration. However, because of the simplicity of the procedure, most manufacturers do not object to a qualified master rigger performing the procedure. It would be wise, however, for the rigger to contact the manufacturer for permission before undertaking the procedure. The following procedure is shown on a Voodoo TM system. Disassembly 1. Measure the MLW to check if the harness is even. 2. Remove the ripcord pocket/MLW cover. Figure A, 3. Measure the lower MLW. Figure B, 4. Remove the lower MLW. Figure C, Reassembly 1. Measure the webbing for the lower main lift web. Figure D, 2. Zigzag the bowtie folds as marked including the Type 4 buffers. Figure E, 3. Glue the MLW in place. Make sure that the open end of the webbing is on the rear and oriented up towards the chest strap. 4. Mark the stitch pattern on the MLW and sew with the harness machine. Use a 3-inch width W pattern at the top as shown in Figure F. Include a box pattern on the lower section of the MLW. 5. Reattach the ripcord pocket/MLW cover. Figure G. Inspection. Check that the new harness dimensions are correct and symmetrical. Verify the harness stitching is correct for SPI and tension. The ripcord pocket/MLW cover must be reattached. Leg pad resizing. Applicable products. Most harness leg pad configurations. Description. Shortening the length of the leg pad, authorized repairman, FAA senior or master parachute rigger, materials, E-thread, machines, 301 straight stitch, medium duty 7 to 11 SPI, 301 double needle with tape folder 7 to 11 SPI, and 1-inch x 42 stitch bar tack, equipment, scissors, seam ripper or scalpel, marking pencil, 6-inch ruler, and hot knife. Procedure Disassembly 1. Measure the amount that the pad is to be shortened and mark on the sleeve of the pad. Figure A, 2. Remove all bar tacks or zigzag stitching from the binding. 3. Using the hot knife, remove the binding from the pad. Figure B. 4. Unpick the sleeve from the body of the pad. Fold the pad under and using the hot knife, shorten the sleeve by the required amount. 5. Measure the pad and mark. Trim with the hot knife. Figure C. Reassembly 1. Using the double needle machine and binder, bind the end of the sleeve. Figure D. 2. Sew the sleeve to the pad and pre-sew the foam with a single needle. 3. Trim the ends of the tape. 4. Rebind the pad starting at the upper corner. Figure E. Make sure the inside curve of the pad is fully captured by the binding. 5. Bar tack at the original locations. Figure F. Inspection. Verify the length is correct. Check that the bar tacks are at the original location. Automatic Activation Device, AAD installation, applicable products, most 1-pin sport piggyback systems. Description, installation of a Cypress AAD to a 1-pin sport piggyback harness and container system, authorized repairman, FAA master parachute rigger, materials, E-thread, color to match, Cypress installation kit, and spandex fabric, optional machines, 301 straight stitch, medium duty 7 to 11 SPI and 308 zigzag, medium duty 7 to 11 SPI, equipment scissors, seam ripper or scalpel, marking pencil, 12-inch ruler, hot knife, and wallpaper roller procedure. The following procedure is representative of a typical installation of the Cypress AAD into a modern 1-pin reserve container system. While providing guidance for this operation, it is imperative that the rigger possesses the proper instructions from both the harness container manufacturer and the AAD manufacturer. Disassembly. Open the right side corner of the reserve container. Figure A. While this might not be needed on some size containers, it generally makes the installation of the pocket easier and it is not that hard to close the corner back up. Reassembly 1. Mark the center of the container wall at the bottom. Figure B. 2. Mark the center of the spandex portion of the Cypress pocket. Figure C. Do not mark the center of the entire pocket. The spandex must be centered on the wall to allow for the correct positioning of the Cypress processing unit. 3. Align the marks in the pocket as close to the bottom of the wall as possible. Figure D. 4. Sew around the pocket with the single needle machine. Backstitch 0.5 inch at each of the corners for reinforcing. 5. Next, install or create a cable channel for the control cable. Some systems, such as the one shown in Figure F, can be modified to provide the channel. Others need to use the adhesive back channel provided with the Cypress kit. Built-in channel modification configuration 1. Mark the bottom and top of the pack tray cover as shown. Figure E. Place a hand tack at the A position. Unpick the stitching between the corner bar tack and the hand tack at the A position. Also, unpick the stitching between the B bar tacks. 2. There is now a built-in channel to slide the control cable through and stow the excess cable as well. Figure F. Adhesive channel installation 1. Measure the distance along the long axis of the reserve container from the bottom of the pocket location to the top of the container near the planned location for the control unit. Figure G2. Cut a piece of the adhesive back channel to the same length. Remove the adhesive covering and position the channel in place. Roll the channel with the wallpaper roller to secure the adhesive. 3. Locate the position for the control pocket. Unpick the stitching that holds the main container to the back pad. Figure H. 4. Insert the pocket with the mouth towards the channel opening and restitch the container to the back pad. Figure I. Make sure the control head fits into the pocket. Cutter channel and elastic installation. The location of the cutter is specified by the container manufacturer's instructions, and should be strictly adhered to. The following location is specified for the Talon system. 1. Lay the Cypress unit on the pocket and route the cutter/cable assembly out the top of the pocket and in as direct a line to the side flap as possible. It is necessary to cut a hole in the bottom launching flap to access the side flap. 2. Where the cable passes through the bottom launching flap as close to the wall as possible, place a line approximately 0.5 inch long. Figure J. Take the hot knife and cut a single slit the length of the mark. Do not cut any other material. 3. Route the cable through the slit and then along the side flap as shown. Figure K4. Place marks along the binding showing the start and finish locations for the cable channel. Again, the rigger can use the adhesive back channel or make a channel out of the spandex material as shown. Figure L5. Route the cutter through the channel and out the end nearest the side flap grommet. 6. Slide the cutter elastic over the cutter and position the cutter over the grommet with the hole to the outside of the grommet and the elastic facing inwards on the flap. Mark the corners of the cutter as shown. Figure M. 7. Remove the cypress from the container completely. Position the elastic sleeve to the marks and sew in place with the zigzag machine. Figure N, 8. Reclose the corner of the reserve container as per the original. Inspection: verify the cypress pocket is sewn with the spandex pocket centered on the wall. Control cable channel must be installed. Control unit pocket must be installed. Cutter cable channel must be installed. Cutter elastic must be installed. Verify the reserve container corner is closed, as necessary. Check the fit of cypress in the entire installation. Log installation data on the packing data card. Remember, this is an alteration. Section 6, Manufacturing. There might come times when it is more practical for the rigger to manufacture replacement parts in order to return a system to operation. The items listed in this section are those that are either main component parts or the reserve closing loop, which is simple to make and usually within the purview of the senior rigger to do so. It is important for the rigger to recognize just what parts are legal to make. One item some riggers make, but one in which they are not usually approved to do so, is the safety stow for the reserve-free bag. As part of the TSOC23D component, it is manufactured from approved materials and under an approved quality control system. As simple as this item is, if it is not manufactured according to the original configuration, there is a very good chance for a failure of the reserve deployment system. The best rule of thumb to follow is this: if the component is part of the approved assembly, then it is probably not something that may be manufactured in the field. The common exception to this rule is the reserve closing loop. The rigger who is undertaking the manufacture of these components needs to have, at the minimum, the following sewing machines: medium duty, single needle, double needle machine with a binding attachment and a zigzag machine. In addition, the rigger needs grommet setting tools and a basic selection of webbings, materials, and fabrics. The following are outlines of construction procedures for the manufacture of the listed items found in Section 6, Manufacturing. Main and reserve closing loop manufacture: main deployment bag, bottom of container, BOC, pocket. Main and reserve closing loop manufacture, applicable products: all harness and containers that utilize a fabric closing loop configuration. Description: fabrication of fabric closing loops, authorized repairman, FAA senior or master parachute rigger. Materials: E-thread, loop material, 725 Spectra machines, 301 straight stitch, medium duty 7 to 11 SPI, 308 zigzag, medium duty 7 to 11 SPI, and 1 inch x 42 stitch bar tack. Optional equipment: scissors, seam ripper or scalpel, marking pencil, 18-inch ruler, hot knife, finger trapping needle or FID, and finger trapping wire. Procedure: the terms locking loops and closing loops are synonymous and used interchangeably. Fabric locking loops have become the preferred method of closing most modern parachute containers. Dating from the mid-1970s, the most common material was Type 3 suspension line. It was soon recognized that other materials, such as Dacron, were superior for this use. Today, Spectra is widely used for reserve locking loops, while Dacron has remained preferred for main loops due to its durability. The following technique demonstrates the fabrication of a 1-pin and a 2-pin loop. Preparation: 1-pin loop 1. Measure the length of the original loop. If the stop knot is too tight to untie, allow extra length. You can always cut it down, but you cannot glue it back on. 2. Cut an appropriate length of material and hot knife one end on an angle. Fabrication 1. Fold the line in half and mark the center. Figure A2. Place a mark at 1 inch from the center on the hot knifed end. 3. Take the finger trapping FID and screw it onto the hot knifed end. Figure B4. Insert the pointed end of the FID into the line at the farthest mark by separating the weave of the material so that the FID then passes through the length of the braided line and out the scissor cut end. Figure C5. Draw the line through until the two marks are aligned. This results in a loop eye of approximately 0.5 inch. Figure D6. Pinch the eye of the loop with one hand and smooth the material from the eye to the end. Hot knife the running end. 7. For short loops used with a main container, simply tie an overhand knot in the loop for the required length. A metal washer is used to keep the loop from pulling through the grommet. Figure E8. If the loop is to be used with a reserve container, it may be required to sew the finger trapped part of the loop for security. If this is the case, simply sew the length of the finger trapped portion of the loop with a single needle machine before hot knifing the end. Start at the running end and sew towards the eye of the loop. Stop sewing approximately 0.12 inch from the eye and then backstitch a minimum of 1 inch. Figure F, trim the end with the hot knife. Fabrication: 2-pin loop 1. Measure and mark the line according to figure G. Cut both ends with the scissors. 2. Using the finger trapping wire, finger trap one end to form the loop and have the running end exit approximately 1 inch past the center mark. Figure H, 3. Repeat with the opposite end. Exit again past the center so that the two lines overlap at the center. Figure I, 4. Pull the loop tight to remove any slack. 5. Bar tack or zigzag the loop ends. Figure J, 6. Trim the running ends. Figure K, 7. Bar tack or zigzag the center overlap junction. Figure L, 8. Measure the finished loop. Inspection, check the loop length. Verify stitching is secure and backstitched. Main deployment bag, applicable products, all sport systems that utilize a main deployment bag. Description, fabrication of a main deployment bag, authorized repairman, FAA senior or master parachute rigger. Materials, E-thread, nylon parapack fabric, type 3 3/4 inch nylon binding tape, type 1 9/16 inch nylon tape, type 4 1 inch nylon webbing, type 4 1.5 inch nylon webbing, type 12 nylon webbing, number 3 rolled rim spur brass grommets, number 5 rolled rim spur grommet machines, 301 straight stitch, medium duty 5 to 9 SPI, 301 double needle with tape folder 5 to 9 SPI, 1 inch x 42 stitch bar tack. Equipment: scissors, marking pencil, 36 inch ruler, carpenter's square, hot knife, and number 3 and number 5 spur grommet sets. Note, this procedure allows for either 1. Duplicating an existing main bag, or 2. Measuring a container to determine the correct size bag required. Procedure layout 1. Measure the container according to figure A or measure an existing bag according to figure B. 2. Transfer these dimensions to figure C. 3. Lay out bag pattern on the parapack according to figure C. 4. Cut parapack and all required tapes and webbings. Assembly 1. Fold type 12 to center and sew to the inside of the bag fabric at the top grommet location. Figure D2. Sew 1.5 inch type 4 tape at the outside tongue location. Figure E3. Sew 1 inch type 4 tape at the outside mouth location. At the same time, sew down the 2 side stow band tapes and the 3 mouth stow band tapes. Figure F4. Bind the mouth of the bag with the double needle binding machine. Leave the tapes long at the ends. 5. With the bag inside out, match the edge of the mouth with the alignment marks on the tongue. Figure G. Sew along edges to form bag. 6. Trim the excess tapes at the edge of the bag. 7. Starting at the inside corner of the bag, bind the inside seam. Figure H. 8. Trim the inside ends of the binding leaving a 2 inch tail. Figure I. Double the tail back and bar tack. 9. Bar tack the stow loops at the appropriate locations. Figure J. 10. Install a number 5 grommet at the top center of the bag. Orient the grommet from the inside with the washer on the outside. Figure K. 11. Install the 3 number 3 grommets in the tongue of the bag with the grommets from the outside and the washers on the inside. Figure L. Inspection: sewing should be straight. Binding should be secure. Verify all bar tacks are in place. Grommets should be oriented correctly and secure. Bottom of container, BOC, pocket, applicable products, all containers that have a BOC pocket configuration. Description: fabrication of a BOC pocket, authorized repairman, FAA senior or master parachute rigger. Materials: E-thread, parapack fabric, spandex or equivalent elastic fabric, 5/8 inch elastic tape, and type 3 3/4 inch binding tape. Machines: 301 straight stitch, medium duty 7 to 11 SPI, 301 double needle with tape folder 7 to 11 SPI, and 1 inch x 42 stitch bar tack. Equipment: scissors, marking pencil, 18 inch ruler, carpenter's square, and hot knife. Procedure layout 1. Draw the shape of the BOC pocket on the parapack fabric to the size required to fit the pilot chute. This will be the base panel. 2. Fold the spandex fabric in half and cut to the same size as the base panel. This will be the pocket panel. Make sure the grain of the fabric is parallel with the length of the pocket for stretch. Trim 1/2 inch off the end opposite the fold. Figure A. Assembly 1. Open the sides of the pocket at the folded end and insert the length of elastic tape. Sew the tape in place with the single needle on both sides. 2. Mark the center of the mouth and bar tack the elastic reinforcing as shown. Figure B. 3. Lay the pocket on the parapack base and sew in place. Figure C. Sewing with the spandex on the bottom and the parapack on top minimizes stretch from the presser foot. 4. Bind the pocket, starting at the bottom corner opposite the mouth of the pocket. Figure D. 5. Bar tack the mouth of the pocket securing the elastic reinforcing on both sides. Figure E6. The pocket is now complete and ready for installation. Inspection, verify that the size is correct. Binding should be secure. Verify the bar tacks are in place at the center of the pocket and at the sides. Section 7, Manufacturing. The following are miscellaneous procedures used in repairs and alterations found in Section 7, Manufacturing, of this chapter. Hand tacking techniques, cleaning and washing procedures. Hand tacking techniques, applicable products, any systems requiring hand tacking, description, securing housings, hardware, etc. With hand tackings, authorized repairmen, FAA senior or master parachute rigger, materials, nylon supertack tacking thread machines. None. Equipment: scissors, assorted hand tacking needles, and modified Navy end tab procedure. Hand tacking is an integral part of rigging skills. There are numerous places where components or parts are joined. Hardware, housings, cones, and other parts require hand tacking to secure them to their positions. The following figures show typical tacking techniques. Pilot chute 1. Take the needle and supertack and pass it through the reinforcing tape at the bottom of the pilot chute mesh, capturing the spring coil. Figure A2. Cross over the radial seam reinforcing tape and again pass the needle through the reinforcing tape and capturing the spring coil as before. Figure B3. Secure the ends of the supertack with a surgeon's knot and locking knot. Figure C. Trim to a 3/4 inch tail. Housing 1. Position the housing end flush with the end of the housing channel. 2. Take the needle and supertack and tie an overhand knot approximately 1 inch from the end. 3. Pass the needle through the inside of the housing channel and then around the outside below the housing end. Figure D. The purpose is to choke the end of the channel so that the housing does not protrude from the end. 4. Next, take the needle and pass it through the top of the channel fabric over the housing. Figure E5. Take the needle and locate the grooves in the housing. Figure F. Make 3 loops through the channel, trapping the supertack in the grooves. Figure G6. Secure the running end with a surgeon's knot and locking knot. 7. Twist the supertack together and trim with a 3/4 inch tail. Hardware 1. Take the needle and doubled supertack and pass it through the leg pad from the bottom next to the edge of the leg snap. Figure H2. Pass the supertack over the bar of the snap and down through the pad. Figure I4. Secure the 2 ends on the bottom of the pad with a surgeon's knot and locking knot. Figure K5. Twist the ends together and trim to a 3/4 inch tail. Cleaning and washing procedures, applicable products, most harness and container systems, description, cleaning and washing parachute components, authorized repairman, FAA senior or master parachute rigger, materials, woolite or similar mild liquid soap and a lot of clean fresh water machines, jumbo tumbler type commercial washing machine. It is not recommended to do this in your home washing machine. Equipment: medium stiffness scrub brush, large pillowcase or laundry bag, wash tub, assortment of rags, and extra laundry. Background: this procedure applies only to harness and container systems. Most canopy manufacturers do not approve of washing their products to clean them. Doing so may alter the performance characteristics of the canopy. Follow the instructions in the owner's manual for each make and model of canopy. Color fastness: it is important to check for color fastness of certain types of materials. Colored E-thread and Type 3 binding tape have shown a tendency for their colors to run when wet or damp. Red is particularly prone to doing so. Before using the following procedures, the rigger or owner should check for color fastness. Do so by wetting a small area of the container including the binding tape and then lay a damp piece of white cotton t-shirt on the wet area. Leave for 30 minutes. Check to see if any color has transferred to the cotton fabric. If not, then it is probably all right to wash the rig. Remember, this procedure in no way guarantees that the colors will not run. Procedure: Disassembly 1. Remove all canopies, AADs, and component parts, such as toggles, RSL, ripcords, bags, and elastic keepers, as well as the packing data card. Hand washing 1. Soak the rig in lukewarm water. Apply straight woolite or soap onto the dirtiest areas and scrub with the brush. Soak in lukewarm water for 20 minutes. 2. Scrub the rig vigorously all over. Soak for another 20 minutes. 3. Continue scrubbing vigorously and soak for another 20 minutes. For particularly dirty rigs, empty the first batch of soapy water and wash in a fresh batch of soapy water. 4. Squeeze out as much soapy water as possible. Immerse in fresh, clean, cool water and rinse several times until no further soap comes out. 5. Hang to dry out of direct sunlight. The use of a fan directly onto the rig will greatly speed up the drying process. Machine washing 1. Wrap the hardware of the rig with the rags to pad them so they do not beat the inside of the machine. 2. Soak the rig in lukewarm water and apply woolite or other soap directly onto the dirtiest parts. Scrub these parts vigorously. Allow these parts to absorb the woolite during the time traveling to the laundromat. 3. Place the rig into the pillowcase or laundry bag and add extra padding, such as extra laundry. Levi's work exceptionally well for this. Tie off the pillowcase or bag to hold everything in. Place in the washing machine, adding more washing soap and woolite, and wash in warm water. 4. Run through at least 2 rinse cycles or hand rinse several times until no soap comes out. 5. Hang to dry out of direct sunlight. The use of a fan onto the rig will greatly speed up the drying process. Scotchgard. The use of Scotchgard brand fabric protector has become commonplace in recent years. This fabric treatment seals the pores of the fabric against dirt and other stains. Scotchgard is not a magical silver bullet against dirt. However, it has shown good results in keeping lighter colored fabric cleaner longer under normal use. Grinding it on grass or asphalt or other heavy abuse still stains and or damages the rig materials. Scotchgard is not harmful to today's container fabrics, such as Parapack and Cordura. There are currently several Scotchgard formulas. The standard fabric and upholstery formula is in the red can. Figure A. Do not use the rug and carpet formula in the blue can. After the rig is completely dry, hang it in a well-ventilated location. Following the directions on the can, apply the protector to the entire outer surface of the rig. For those areas, such as the inside of the leg pads, back pad, and bottom of the main container, and light-colored panels, such as white, etc., apply a second coat after the first has dried. Do not intentionally spray the hardware, housings, and clear vinyl cypress window. After the rig has dried, it may then be reassembled and placed back into service. Chapter summary. It is very important that any repairs or maintenance of the parachute and its related systems are done correctly so that the parachute is always airworthy. This chapter provides detailed step-by-step procedures for many repairs and alterations that can be done by both senior and master riggers. All riggers must learn to identify conditions that may be unsafe and learn how to undertake the necessary repairs to return the parachute to its original, airworthy configuration.